no walls amongst the line. There's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe is all view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie making power for days. Don't listen to a word that the straight no says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tones from the prongs. Burning breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the doping old man Bills.
Hello everybody and welcome. My name is Nathan, otherwise known as Old Man Bills. Joe be here in just a minute, man. What's going on, guys? Yanni, Dennis, man, how's everything going? Hopefully you guys had a great new year. I know I did. Everything's working real well over here. Man, can't wait to take out the Christmas tree and clean up the house, man. It's been full lately. I got a small little house, so works out. You got in 50 caps today. Nice. What are you building now? What's going on, Aaron? Yeah, man, I got to get a lot more capacitors in, to be honest with you, man. I want to get a lot of the blue ones, the smaller ones about this size, probably about a little less than a size of a quarter on the diameter of them. But yeah, I'm there with you, man. I can't wait. When Joe gets here, we'll start talking about it. But learned a bunch of fun stuff about capacitors and energy today. And for the last couple of weeks, man, deep diving into it. Let's see. The latest build takes 23 total. Wow. Nice. Yeah, I love capacitors. So are you just building what do I want to say, like a super cap? Is that what you're looking at? Try to put them all together and make a super capacitor out of all of them? So that's one of the things on my list. I know I saw some people out there using one, man, and it acts just like a battery. It's pretty interesting exactly what they're looking at there. But they sell them, I think, on eBay for $26 for, I think it's 5 caps or something like that together in a row with the board attached to it. I wanted to pick one of those up. eBay seems to be, better price than Amazon. Was like $53, I think. So I wanted to pick up a super cap myself for that reason. But there was energy conversion, man, what we're doing. Kind of ironic how the energy itself will go into capacitors. So I kind of wait for Joe on that one. But yeah. Well on, brother. Happy New Year, man. Oh, man. What's going on, man? Oh, it's going to be a fun episode, man. So let's check real quick. Joe, what's up, brother?
Hey, everybody. Happy New Year.
Oh, man. We're going in, man. 2026. We're here.
I love it.
Oh,
it's
Joe.
A little weird. My screen's a little messed up. I can't see our screen.
Oh, really?
But, yeah, that's on the StreamYard end.
Huh.
I might have to jump out and jump back in. I apologize.
Nah, do what you gotta do, man. Get it right.
All right. Bye.
I should have told him to fix his hair too. Oh man, it's great. I love it. Oh yeah. So guys, we're building capacitors and stuff on open air capacitors, man. It's funny how it works. I don't think the capacitor cares what kind of energy goes into it. And I'm going to prove that theory out. It's kind of ironic the way it works. And hold on, here's Joe. Joe.
Oh, it's still exactly the same way. Okay.
Just not working for you today, huh?
No, well, it's going to be hard to discuss things on screen. I feel like they changed something in StreamYard, but okay.
I have no idea. They keep changing things like every week.
Yeah, I don't know, because there's two. Yeah, it doesn't matter. Oh, look, that is new. Okay. Well, there we are.
You got it set now?
It's actually better.
Oh,
Yeah,
okay.
it's actually better than it's been. Anyway, hello everybody. Technical difficulties aside, of course.
Oh man. Okay, so Dennis is doing a DC flyback spark gap build with Odin coil, 9 turns primary. Nice.
Nice. That sounds kind of familiar to me. Sounds very similar to what I was messing with.
Yes, it does. Joe, check this out. I did a deep dive into capacitors, okay? Because
Mhm.
as we know, we're making an asymmetrical capacitor for the Gravity Flyer, which, by the way, I have 3 plates coming in, 16-inch plate, so new center plate, new
Okay.
top and bottom. They're all solid aluminum, so no bumpy stuff, so all rigid. And I'm going to have those here in the next week. So we're going to be taking Gravity Flyer number 2 and transferring all that over to that.
Oh, well, that's really exciting. That's very cool.
Now, here's the fun part. Okay. We're learning about capacitors. Does it matter how you fill your capacitor? It's kind of an interesting question.
That is an interesting question. Okay.
So beyond the capacitor, let's see if we agree here. You can hook any motor you want to it beyond the capacitor. You just have to work on your duty cycle to it. You know what I mean? To
Mhm.
get it to run. Would that be fair?
That sounds good so far.
Okay. So filling the capacitor, what I learned was it doesn't care one bit what the energy is. So let me qualify that. We normally take iron and we take copper and magnets, right? That's how we do our normal generator. Okay.
Mhm.
And you think, man, I got to get a big amperage. I got to get, a lot of, so I can run a lot of the load.
Mhm.
But then if I take aluminum and I use copper and I use magnets, you'd say, well, man, you're pretty much screwing it up, Nathan, because you're not getting enough amperage to it, right? Did you know the capacitor does not care whatsoever between the two? The only thing it cares about is how fast the capacitor filled.
Yeah. Okay. I kind of get that. I mean, it does make sense when you kind of think about it, just like in the most simplest forms. When you realize what a capacitor does and how it works, you realize that what you're putting into it doesn't necessarily make all that much of a difference because it's acting as a kind of a blockade, you know, to capture and provide resistance without loss, really, until it's able to discharge. And it's sort of like whatever you throw into it, whether it's radiant energy or direct, or, the like current of, either AC or DC, it almost doesn't matter now that I'm kind of thinking about it because it's doing the same thing. It's creating that resistance that's basically squishing the waveform. Think about everything as a waveform that starts to make sense that way, right?
Right. So it basically builds a dielectric field, is all it's doing, right? Between two
That's
plates.
exactly it. At the end of the day, yeah, gets held
So
in until it gets pushed out.
here's my favorite part about it. This is where people get screwed up. How much current does it take to run a motor? And they go, well, you can't run a motor on a Tesla coil. You can't run a motor on a high voltage potential. But that's only true if you're going straight to it. It's not
Mhm.
true if you put a capacitor in the middle and make it the wall. It makes it
That's
separate
exactly
the.
right. That's exactly my words on it. It's a wall. It acts as a wall. It's because and like a wall, it acts like a well, right? So we've talked
Yes.
about you got to take it from the well. Well, that's sort of what the well is. It's where it could build and gather and then come out as it's needed at the pressure that it's needed at. It acts like that well.
Exactly. So here's the best part about it. Okay. Depending on which capacitor you have, is how well it fills to the energy you have, right? So what I was looking at is if you took aluminum and build it as your generator, what it actually means is it has a very low impedance. So as the magnet rotates, it's not hitting that much of a wall. It means that you can reduce the size of the motor. So you're reducing the amount of energy it takes to create the same amount of energy into the capacitor.
Yeah, that's a good way to look at it. And it's not often discussed that way.
So now we go into battery technology. What if I simply said, okay, in the core, I tried barium titanate, okay? And I wanted to try something that would spike when energy is put into it, which means that I'm going to get a higher amount of energy coming out of it because they're used in piezoelectric discs all the time.
Mhm.
So what happens when I do that is it increases this rate of speed that the capacitor fills.
Yeah.
Well, that's kind of the
Yeah.
trick, isn't it?
Right. I mean, well, that it's just a closed system of an exchange rate at that point, isn't it?
Yes.
Um, it
It's
comes back to the same concepts over and over.
But this is why transistor physics matter, because it's the material science that they've already provided telling you what each part does in sequence with each other. Now, if we apply that same material science to our actual uh, I'm looking for a word, transformer. If we apply it to our transformer, now we can get to something that's much better. We apply it to our generator, we can now get a much better output. So because we're not using the correct material science, we're not seeing a better generator. We're seeing the same generator built over and over again. No matter how you geometrically put it together, it's the same material. The failure is keep doing the same thing over and over again.
Right, right. Well, I mean, we tend to overcomplicate things when we talk about them oftentimes, don't we?
Yes.
Sort of what it comes down to is you have potential, and if you could take that potential and turn it into a vector state of any vectoring, then at at the end of the day, you now have, usually it has to go through a current state first, right? Because it has to work its way up the dimensions. So when you bring it out of that potential state and then you work it into the current state, you could then do with it as you need to. Then you could bring it from DC to AC also, and regulate it. It's just all about getting it out of the well. That's it.
So check this out. I was watching Bedini, and that goes along with what he's saying here, the bifilar coils of Bedini, right? He goes in a video and he describes the second coil that he puts on there as a capacitor. Okay? He's not saying capacitor, but it's exactly what he's describing. So he's telling you, here we go. We have a zone in the center, acts as a blotch wall, right? And it goes off both sides. Okay? And we've seen this in the coils of the Tesla coils, right? And then it fills in the energy. And then he says this. He goes, as you fill it, it goes like this, and this to each other, right? So what is it doing? It's building volume of energy inside of a capacitor while pushing the capacitor walls to be thinner and thinner and thinner, right?
Mhm.
But it's building up the capacitor. And he says that's the vacuum that pulls into the capacitor of that coil. So think about that when you're trying to figure out what the capacitor is, because it changes, but not in the way you think, because there's still fields between fields. Okay. No matter how many turns you put on there, it's still a field between field, and it's still a capacitance in between the two. It's just different in our minds, the way that we're thinking two plates, saying it goes in between two plates and all this with all these little balls and electrons. But then
Mhm.
Bedini tells you, no, I could just take this coil and wrap it around in a bifilar manner and make it into a capacitor as well, because it
Yeah.
does the same exact function, just the geometry is a little bit different than what
Yeah,
you're thinking.
absolutely. Yeah, I mean, so anytime that you're making something that has a gap, there's going to be a certain amount of capacitance that exists within that interaction. It's like parts of the whole. You're still going to get magnetism off of a bifilar coil, because at the end of the day, it's again creating the rotational vector. It's adding in that extra movement. But because it's also interacting sort of with itself in its own fields, and the wires are not necessarily all touching, they're bundled up in separate as they go concentrically around. Those gaps allow for the building of capacitance, unlike one of the Tesla coils like you commonly build, where the wires are pretty much pressed up against each other like that, and then they're arranged in a vertical fashion, stacked like that, right? So those aren't stacked; those are building outward, and it allows for there to be a much greater degree of capacitance. Whereas it just really isn't as much the case. Where it's building out exponentially as it goes up, like on a bifilar with the Tesla coils that you build. Yours, you kind of have more of a certain amount of capacitance that's the sum of the whole, whereas those build up incrementally because it, as it builds out, it should have more and more capacitance the closer you get to the center because of compression. And it would take some while for that to saturate and get to that state. It wouldn't be instantaneous, right?
So yes, it would take a while to get there at first, yeah. So it would take quite a while, but it's acting more as a capacitor pump, is what he's saying. It's pulling in like a vacuum, like a pump would. It's creating a gap in order for the energy to come back into it, is what he's saying.
Yeah, it's about the surface area and the fact that the surface area and the idea that the waveform that's running along those conductors are able to mingle and able to induct from one to the other. There's an induction that occurs, but though it's still inducting, it still also has its current state that's going around in that direction as well. But it's that addition of the inductance that introduces the capacitance, increases the capacitance potential.
So does he also have eddy current running into it?
The eddy currents would run transverse of the plane, so that's how they work. You would, except it's not in the same sense that we see them when we're talking about more traditional, magnetic components and magnetism.
Because he has a core in it. Just remember that too.
Yeah, because it would go through the coil and then back around. It would have to. So the geometries change because the nature of it in itself is that it's actually running it's running the magnetic component of a bifilar coil on a plane, is what it's doing. That's why it's built outward.
Mm-hmm.
And it's flat like that. So it's running it on a plane. And then it's exploiting the distance, the gapping of the distance. So, yeah.
I think the reason he picked up more energy, just personally, is he's taking three separate waveforms and combining them into one and shoving it into a capacitor, because a capacitor does not care what kind of energy it is. It cares the amount. Mm-hmm. And what he figured out was the angle, the direction of each one. So if we just started out and took a clock and said, okay, the first one's at 12, but then at 2 o'clock, we pick up another energy. But then at 3 o'clock, we're picking up another energy. But what happens when I take 1, 2, and 3 and put them together and drop it into a capacitor? Then the amount changes, right? So as he pumps it in and out of that coil, it's letting it grow and pulling it in. Pretty soon, it's sucking more energy through the first coil that he had in there. So he pulls more through it, like it's a negative energy. And when you pump the negative energy, we all know it pulls through. And he's just pulling it faster now. So now his cap, he's adding a draw to the whole system, which makes his cap fill up way faster.
Well, let's draw some correlations here. Okay. So again, let's oversimplify things, because they really are that simple in like the root point. Well, what is a capacitor in the first place? Well, a capacitor needs components. It needs all of the components, right, in order to work. It needs a conductor, and then it needs a dielectric and an insulator. So it needs something to pull energy in, push energy away, and then not let it move. That's how it works, right? That's
Mhm.
what having those three components are. Well, it's like we say that whenever you're looking for the more outstanding phenomena, you need all of the variables present in some kind of relationship with one another in order to get the effect, right? That's always the case, right? So you need the static current, um, a magnetic component, scalar component, in order for things to actually build up into the higher dimensional process that then gives you effect. Same thing here, except you're dealing with materials. You need all the materials in order for it to build, compress, and then blast out. It needs to be able to come in, come out. So it needs the conductor, but it needs the dielectric and the insulator to allow it to build. Either that or we just have a direct path out.
Mhm.
So it really is that simple, though. Like, it's, you think about a capacitor. If you were to, pull one out of something that you have or whatever, you take a look at it, you're like, man, this thing is like, I think, like highly secret. Yeah, I have to take a razor and break it into pieces just to see what's inside. You pull it apart and you realize, well, there's not that much going on. Well, that's why. 'Cause that's
So,
just how it works. It's just exploiting the materials.
so check this out. So we know that the gravity flyer is an asymmetrical capacitor, right? So what does that mean though? It's now that I know this, if we connect the top and bottom to DC flyback, right? So it's like a DC pulse. Okay. But then I turn on my Tesla coil in DC. I'm already connecting in capacitance. I'm already filling the capacitor. Okay. I don't really realize it yet, but I'm pulling in all that energy, right? But what happens then when I turn it to an AC? See, that's the trick, isn't it? Because
What are you talking about?
how does AC capacitor drop? It's like a shark fin, right? It goes up at a high point and it doesn't go back in, but it goes out like this, right? So it has an immediate spike and then curves back out. But that's not the way a DC capacitor jumps out, right? So, and it's also not going to play with eddy currents. But as soon as I change it to AC, I have now just fixed it the right way. But let's go one better. Let's go into the Tesla playbook. Pulsed DC signal instead. Even stronger. Okay? Just think about that for a minute and what it means. You have a square wave that goes to a certain height, right? But what does the DC pulse do? It goes right over that square wave as an amplification to that and goes back down. So I've already set the duty cycle. I'm just
Yeah.
changing the amplification of it and putting it into a half AC form where it then spikes all the aluminum and the eddy currents. I just created a massive energy surge in the capacitor.
Yeah, I mean, so and you bring up another good point about the DC and capacitors and eddy currents when you mentioned the three of them together. Because realistically, if you think about it from a hydrodynamic perspective, um, anything that's pulsed is going to take a far greater time to reach any form of stable laminosity. And it's that stabilization of through luminosity past a certain threshold that allows for persistence of eddy current, that aka convection, right? So if you just think about it mechanically in simple terms, right? If you have a convection oven, right, and it's driven by a fan, well, it works, right? Why does it work? Because the fan is the motor is spinning, the bearing allows the spinning consistently, the spinning is going in cycles every time the blade chops, sure. Okay, but the fact is it's spinning consistently. Now, if it's just pulsing out and it's basically taking a break, okay, it could produce the same effect, but because it's choppy, right, it would actually have to work a lot harder and take a lot more of, to the point where those pulses are almost negligible, right, in order to create the same stability and luminosity. And that's where the AC comes in. Why they're good at forming eddy currents.
Hmm.
It's just another way to look at it. And, just again, another correlation. So if you're looking for certain things and you're using certain other things, right, you might be using the wrong type of energy configuration to get what you're actually set out to do.
So let's take this a step further, Joe. If we wanted to pull the atmospheric energy, or what Tesla calls radiant energy, does it matter to the capacitor at all?
I think it does and it doesn't. The answer is it probably just doesn't, because if you think back to my chart, there's weird stuff that goes on in it with the relationship between AC and DC. And one of the weird parts of the relationship is that even though there's no frequency, the pulse rate of the DC shoots off exactly 2 times per node antinode cycle. So for every waveform that occurs in the AC frequency, the DC pumps out twice. But the odd thing is that the wavelength of it is actually longer. Even though there's no wavelength per se, the pulse rate duration, we'll call it that instead of wavelength, pulse rate duration is actually longer with DEC than it is with AC to pass the same point twice. So it'll actually the AC will come up and down faster than the DC pumps twice. A high and a low. Yeah. It was a strange thing to see, but it works out and it's consistent. It's because the average of the two is the same.
So, okay, so let's trick the energy a little bit, okay? And we're going to just do it with like a Casimir effect.
Mm-hmm.
Now, if I take that same radiant energy and I put 2 plates and I change the distance between them, then what happens? I eliminate the long form and I get very short form waves, right?
Yep.
So
You're going to discriminate out a lot of waveforms, and then the ones that do fit will get compressed by the dielectric.
Now put that into a capacitor much faster, right?
And instant, like a laser.
That's kind of the point here, isn't it?
I would say.
We're looking at different energy forms, but we also have to look at the time it takes to get from one distance to the other between each wave, right? So the faster we can get that to go, it's better. But then that defies the way that energy works sometimes, because you look at a Tesla coil and it's all about super high frequencies and stuff like this, right? But it's not that. It's the amount of energy that's in there. See, Tesla coil would put out the energy in high spikes, but the amount of energy is still less, you know what I mean, than it would be compressed. So yeah. It's kind of a crazy thing and how you have to wrap your mind around it, but you have to just keep thinking of what it's doing and why it's working and which geometry you want in order to pull it out faster. So we're doing Tesla coils wrong, Joe. We're putting them directly into a cap. That's a failure on our part, or my part at least.
Well, it's funny that you say that, because when I was running my RAV experiments, I built myself a capacitor and I was running it right into the capacitor.
Yes.
And I was able to, because it was somewhat limited of a capacitor, it was homemade on top of that. It was also ridiculously dangerous. I was able to get it at a constant discharge,
Mhm.
so because I was filling it up so much, I was able to also, keep it running. The caveat to that is back EMF again, because anytime that you're compressing that much voltage, and whatnot, you kind of run that risk.
So there's a way to fix that, Joe, and I think I sent it to you, but I don't know that I built it and showed it to you. It's a
No,
snubber.
you told me about it. You told me about snubber circuit,
Okay.
yeah, but yeah, we never really expanded on it.
We're going to have to build one this year, okay, for sure, because I'm going to need it in my setup too. What I'm actually getting at with that is it pulls the energy, put it back into a capacitor, and then it runs it through the system again. So any back EMF you get goes right into that capacitor and it fills it up and gives you a higher discharge when you want it. Or you could fill a capacitor bank with it or anything else. It's the same thing as a Bedini spike. It's this back EMF, right? So we'll
Yeah,
just use, a circuit to pull it off and dump it into caps, which actually works out better for you. The amount of energy going into your system, if you put caps on it, okay, between the positive and negative when it goes on, you'd actually have more energy, which is scary, by the way, in that Tesla coil than
it's
you
scary.
did before.
Yeah. I mean, like, I was watching back some of the old rad videos I was doing and stuff, and I was like, this rad was frightening. I'm like, yo, this particular rad was frightening because it wasn't ever a big sphere like Sean's, or like it wasn't even a bleeder like yours. It was just this small, immensely bright immensely bright, that put off almost no ambient light whatsoever, and just like I think it only took about less than 1 minute to run the current through that rock that I used as, the intermediate, in place of clay. Like, that's insane. The rock was 3/4 of an inch thick. You know, it ran a
Well,
channel right through it in less than 1 minute. Like, it's like Stranger Things when they were breaking down the barrier of the underground. They were just blasting it until like it would, go away. Same sort of deal.
oh yeah, well, you see now why I sent you that video a while back on digging with one of these tips. It digs right through everything. It literally blasts everything out, makes it into what is that? The black glass that, that they
Right, but
come
the
up with.
messed up thing is, and I think the thing that people don't realize, and this is why it's so dissimilar to like welding and stuff like that, right? Is but it doesn't destroy the stuff that necessarily in the same regard, like just running a hot arc on something. Like, it doesn't puddle and pool the material like that. It doesn't do that. It literally just it digs itself through the material and is just leaving deposits along the way. Of what it needs, from what it's taking and what it's creating is sort of what it's doing. It's just strange because, like, usually hot arc melts material. That's how it goes. But that's not exactly what we see.
So let me say it this way: if you were a sculptor, would this be a helpful tool in getting rid of material that's in your way and you sculpting like a face or something?
I don't think so. Because mine didn't dematerialize anything. That's what I'm saying. It just channeled through. That's all it did.
Oh, okay. You weren't
Yeah,
ripping things
yeah,
off
no,
the
it didn't
surface of it.
dematerialize anything. I'm saying the opposite, in fact.
Hmm.
It creates its black channel, like that we've talked about 1,000 times. But it really only did that so fast after I added the capacitor, by the way, directly to the anode. Directly to the anode. No, waste no time, no switches, no circuits, no nothing. Straight to
Yep.
the anode. There was a little. I left a little tiny spacer in between. I just shoved a plastic spacer to keep my. I had a carbon graphite, like a pencil blank, that I used as the anode and and I gapped it with a piece of plastic. That's how I kept them from touching and create a circuit
Hmm.
in the cap. It was a pisser. It was funny.
Hey, it works.
It seemingly did, but yeah.
It's the only video to date I've ever seen a piece of crystal shine from the inside with all the light.
Yeah, I realized I actually have more than one. I have other videos that I discovered. I think I was so tied up in experimenting on it, like over a few day period, that I don't even know that I reviewed all the material entirely after I blew that one crystal up, because everything just seemed kind of like maybe insignificant to it. But when I went back and I recently watched some footage, I had a whole nother piece of quartz that I had a wrap inside of.
Yeah.
And it didn't blow up.
Yeah, I agree. There's things going on in that wrap that aren't normal. Not in any way.
It's not normal. Things don't do that.
Things don't do that.
Things don't do that.
Apparently they do. Did you get a chance to watch any of that video that I sent you on Danny Jones, and he was interviewing that guy about the pyramids?
You know what? No, I've been so tied up the last couple of days, that I haven't had a chance. But yeah, I mean, tell me about it a little bit.
Okay, so he's using they want to use lightning, okay? And here's how he describes it. Lightning comes in and strikes at the Great Pyramid. The Great Pyramid is basically filled up with water because it's got a candlewick effect to water, right? So it acts as a giant capacitor. Then in that, it distributes energy and gas into the Red Pyramid, okay? Which then it makes, oh God, I forgot the name of it. Oh, come on, it's in fertilizer. I forget.
Nitrogen?
Not nitrogen, another one. Ammonia.
Ammonia, okay.
It makes ammonia. So then the ammonia goes over to the next pyramid that's there on the plateau, and it goes over and then it pulls out all the bad stuff that's in it through water, okay? And then it goes through this little valve that pulls out just the gas itself. So they're able to convert it. But the cool thing was they were looking at the high voltage or the strikes of lightning that come in there to fill the capacitance of the pyramid itself, which, by the way, is factually 100% true on how those materials work. And yes, they will create a capacitor. And yes, it is based on the same physics as a regular capacitor when they do it. And yes, it will fill it up in the same way, though it will be leaky. So you only have a certain amount of time to use it, right?
Yep.
The cool
so check
thing.
This out. Hold on. Here's something that wasn't in the video, even though I didn't see it yet. I can promise you, but I did say this previously, but it makes sense why now, right? So you had mentioned what was in the video was the pitch of the walls being 52 degrees.
Oh, yes.
And when Nathan and I were discussing what I think is wrong with the gravifier, and I was mentioning the longitude, latitude, and how you have to be parallel to the fields and parallel to the rotation in order for these things to really function properly and work. Well, what you find out is that back when the pyramids were likely built, being even older than we suggest that they are, okay, that the relationship between Giza and the magnetic North Pole of where it was at that time was exactly 52 degrees difference. So the pitch of the walls was compensating for that angular differential that we were talking about all along in it. And the other thing about it too is that what's the implication? Because it's not, and we talked about thresholds, right? We don't know exactly what the threshold is, but we know that there's a degree of tolerance, right? That exists. And the fact is that just judging by that, if it's true, it definitively proves that the pyramids are much, much older than 4,000 to 5,000 years old. Because realistically, the only thing that could cause the magnetic North Pole to shift so vastly over that span of time is the ending of the Ice Age. So that they had to have been built at least during the Ice Age, like aka before the flood.
Yes.
Yeah. So that's sort of the reality of that situation. And if you look back and you say, well, what was the relationship 10, 11, 12,000 years ago as opposed to like 44 or 5,000 years ago? The difference is 52 degrees between
Right.
Giza and the magnetic pole at that time. So it's a huge correlation that I drew that correlation by asking those questions um, when what Nathan and I were talking about was relevant to the pitch and angle of the gravity flyer or your reactions that you conduct and such, and there's still stuff that we ought to do with the raft too, pertaining to
Angles.
angles and direction.
Mhm.
So that stuff's got to be up and coming.
I agree with that. Real quick. Darren, I want to thank you, man. 5 Old Man Build memberships. Dude, awesome, brother.
Who's
Taking
better than
care
you?
of me, man. I went ahead and did the same, man. 5 Old Man Build memberships, man. So 10 people out there, man, got new memberships.
Good deal.
Congratulations, all those people, man. And it's going to be a fun month for you. We got some cool stuff that's going to go on, man. So get ready for that. Anyway, yeah, that angle mattered. And let me just say what he was trying to say. And some of the stuff is that he called it white horse lightning, which is basically the lightning that comes out of the sky. They would build monoliths around everywhere in order to capture that lightning. Okay, and they would. I want to say it's theoretical currents or something like that. I can't think of the right word for it. It's close to that word. Anyway, they put the currents in the ground, and what happens to the ground? It allows for plants to grow 3 to 4 times faster in
Mm,
any given area. Telluric currents is what they were called. So
right.
that's why they were saying that the Giza Plateau in that area might have been green the whole time because they were using lightning in order to feed the ground energy. So I thought to myself, here they are playing with telluric currents, and that's what do you think one wire energy does?
Well,
When
right. I mean, that's working just like Orgonite at that point does. It's working just like the planters and stuff that they have. That's just a copper coil spiraled down and with a crystal in it, working that same exact way. And it's working the same exact way as I mean, frankly, a whole bunch of other stuff too. It's look at the obelisks. They have these obelisks all around, right? Well, that if a pyramid's putting energy out by drawing energy in also, well, that the obelisks are, they're receivers at that point. It's basically like an ancient form of a Wi-Fi booster, right? Like it's picking up, the amplified resonance that's being put out, and then it's doing the process again, and then putting it out bigger than it came in, bigger the sum of the whole, right?
I found it so interesting how it all ties in. Because you remember we were talking about this. We were talking about the pyramids, and we were talking about what was it? The civilization before
Mm-hmm.
all of this. Okay,
Atlantis, yeah.
Atlantis, and they were talking about the energy and stuff, and we pointed this out every single time. You know what I mean? Comes
Mm-hmm.
from lightning, and Liz was telling us the same thing that they were pulling this stuff in, and we had talked about the flowers being grown, and they had different energy so that they had different spikes in the proteins in there. And it's ironic because as soon as you use the one wire energy, like we do with the, just the wire down the center, it gives you that, but it does the same thing as lightning going into the ground. Okay. Gives you the same telluric currents. That's amazing. Okay. In itself. Okay. But I found it so fascinating, man. All of the stuff she said comes true.
Yep.
It's becoming ironic. every time I turn around, it's becoming true, and everything we're looking at, we just didn't design it the right way. We keep designing things the incorrect way. Like,
Yeah, good way to
for
look at
instance,
it.
take a piezo, put it in your hook it straight up to your frequency generator, put it in sine wave, okay? Slap it right on the side of a piece of quartz, right? And then just scroll through your frequencies. What it's going to actually do is it'll find the mechanical frequency of it as it scrolls through, and it'll take that piece of quartz and do this to it all day long. It'll
Mhm.
vibrate it. And you're thinking, man, that's a lot of energy in there. How come we didn't do this before? Who's not doing this on YouTube? You know what I mean? Is what I was looking at. So I started looking it up. Who's doing this, man? Is there any person? I haven't. Mike told me about it too, and I haven't seen any video. And I'm going, all right, this is one that's on the list now. We're gonna, because I got a big piece out there. We're gonna have to hook it to. I just found
Yeah.
it ironic, man, that some of this stuff is activated by water. Some of it's activated by ultrasound. You know what I mean? Some of this stuff is activated by the magnetic field, but then that's material science, isn't it?
I would think so. I mean, it's you have to bear in mind that there's so many things out there, and oftentimes, I think of something and I'm like, that can't be right. I've never heard anything like that before. And there's a lot of people out in the world, and a lot of smart people at that. Like very, very brilliant people that will, think you or I right under the bus every single time. But what it kind of tends to be is that sometimes you find something that's bright, that it's not that nobody else knows it, it's that the people that know it, they're just not there to talk to you about it. And they're not talking about it for all the same reasons. And it's interesting. Sometimes I feel like we let a lot of good ideas that we have slip, just because it's like you look to try to verify it and it's like, oh, I guess not. you know, and yeah,
Yeah,
it's like,
I agree. Something simple like that we should be able to verify. So I do have the piezo disc, and I do have some quartz, some milky quartz. And we
hey,
just find,
that'd be a great discovery.
yeah, well, it'll just prove out what somebody else said. I mean, it's not like I came up with it. I just heard it and I go, well, we're going to have to do it because it shows mechanical resonance in something, because it takes mechanical resonance inside of crystal in order to get it to light up.
I think what I want to see you do is I think I want to see um, you hook your Tesla coil up grounded to a piece of pipe down a well. I think that's something, to be honest.
Pipe down a well.
Yeah.
What are you looking to get out of that, by the way? Just
Huh?
curious. What are you looking to get out of it? I'm just curious.
Well, I think that if you could bring the small portion of the well, just like the part that's on the, that has the water hold in it, right? It's a much smaller volume than that which it's connected to, but it has all of the potential and all the resonance factors, okay, of the larger system. Do you see where I'm coming from?
Okay.
So you have an isolated amount of water that's way below the surface. Some wells are they could be 100 feet deep.
Yes.
Like, so you're getting way down there. It's in a mass of that particular water table aquifer, and it's at a true and undisturbed resonance, right? So now, if
Okay.
you're able to bring your Tesla coils energy, you know, and have it act like a pump, like it is, okay, you can pump the ground if you could bring the ground into coherence with it.
Okay.
It's about the coherence. So if you're able to bring that smaller sum of water into coherence, but it's connected to the greater whole that is a well of potential, well, all of a sudden you have access to a much greater thing. That's what I'm saying.
Hmm. I I get it. I'm thinking about it, Joe. Well pipe those big.
It's big, but it's not as big as trying to resonate an entire aquifer.
Oh,
You know, like
it's not that. Is if it's say this size, right? Say you got a 2.5 inch, 3 inch piece, 3 inch, it's probably 2.5, right? And that's your well pipe. In order to get the thing around it, well, I do have that big giant Tesla coil. Okay, from Courtney, and that would be the right size to put over something like that.
I would think so.
Okay, there we go. Now we got. That's what I'm trying to figure out. Just how exactly it would work and which one would use. That one got me good, man. It built up some energy in that thing. Yeah, it got me pretty good that day. Yes, I agree.
Yeah, you'd probably also watch your plants grow in that fashion
Oh yeah.
because
Well,
you'd be drawing it all up, and then it's all permeable. So
mhm.
you'd be, there'd be a state of diffuse, energy that comes off of it as it's rising, as it's coming up. So the whole ground would be, have a much higher state of potential.
Yeah.
It'd
Oh
be a
yeah.
hot spot for lightning strikes, I'll tell you that.
Oh, well, yeah, probably.
Uh-huh.
But then again, man, I got. Oh, that would be cool. Okay. Oh, that sucks. You know those big crapper tanks they have in the backyard. They had to fill it in with sand when they put in the regular pipes. I was gonna say, man, just fill some water in there,
Yeah, just
man.
running into a cesspool, you'd be charging up some old shit from 100 years ago.
I guess I'd have to create something different at this point. A 5 gallon thing and put it in the ground, whatever, just to show that it's operating in one system.
Well, I mean, listen, that's a hell of a way to find out that there's methane still down there. you know?
I'd blow up my backyard, playing with the shitter tank.
Right.
Oh,
It'd be like one of those like fires at the refineries where it's just constantly burning off hydrocarbons. Like it'd be a flaming Tesla coil.
oh my God. That makes so great TV. Yeah, I plugged this pipe into my shitter, lit it up, and now fire keeps coming out of it.
Let's say, if you have a Tesla coil grounded out to an old cesspool, I'm telling you right now, you'd have electric, you'd have fire, it'd be a spectacle.
That'd be awesome.
Yeah.
Oh my God. Okay, that's outrageous. All right,
I don't
well,
know that those were Tesla's ideas, but I digress.
I do not think that they are. Uh, no, that is fun though. Oh God, I mean, I should think things through before I do it. I once did that to a gas tank. I went ahead and said I need the pipe come out to a different direction, so I cut it, and then I go, oh well, it didn't blow up on me, with all the arcs in there, so let me weld it. And then all of a sudden you see a flame come out the end of the pipe every once in a while, and you're like, well, maybe there is something in there.
For real.
You really don't think about it right away until that happens. And then if you're smart, you go, oh my God, the compression in there might kill me. But if you're
I,
stupid, you keep welding.
the,
Oh man. Yeah, the septic goes boom boom.
yeah, isn't that the truth? Listen, I still think you should do it, but I stick with the well. I'm gonna put the naysaying hat on for the tapping into the septic tank. Too many problems.
Stick with the well. I love it.
Yeah, exactly. Stick with the well.
Yeah, I guess that worked properly. But okay, so what if you grew the plants? Oh man, this is going into a little gardening. When they put the plants in there and they just run water through the rocks itself, it actually grows the plants, right? And you can pump that water all the way around and keep doing it. So then putting in the Tesla coil over there into the main source of water would allow the energy to pump through it. I think we talked about this once, but there'd be an interesting thing to see if it grew them faster.
It would be. I mean, I'd love to know about that. This is going back to the stuff that we haven't talked about in a long, long time, like the actual benefits of the things that we look to do.
Oh yeah,
we we get so caught up in like, oh, look, pretty plasma ball, no vacuum. Look, science. And then we get tied up in that. It's like, oh yeah, wait a second, this could actually help. I forgot. It's funny.
Yeah, we'll have to look into that since they did that video on there. I might have to pull out some coils, man, and do some water experiments with them. So, because it ties directly into what they're doing. So,
Yes, it does. Hey, well, we have a second, and before I forget, because
yeah, go for it.
I was going to mention it at the beginning, but I think next week, that's the plan. This coming week, Nathan and I are going to put up for sale to raise some money for between the two of us. Some Tesla portraits that are going to be nicely framed. Okay, and it'll be framed in a black frame and say, with a Tesla's signature in silver. And I did that portrait. So, we were going to put them up and see if you guys are interested. I'm making them limited edition. There's only going to be 25 of them that we make. And if anybody's interested, keep your eye out for it. There's just a couple of tweaks I want to make to it and my process, so they're perfect before we release them. But I should have that worked out this weekend, so keep your eye out for that.
Joe, put it up to the camera again. Is that 3-dimensional?
Like,
is there depth to it?
This is my proprietary art process that it's called accretive deposition. It's ink.
That's awesome, man.
Thank you.
So, are you seeing the same thing I am? It looks like there's depth to Tesla versus the coil.
Yes, it's accretive deposition. So there's about 30 layers that go into creating that.
Oh, dude, that's gonna be awesome.
And it's just built up incrementally. Like it's basically like I do it like oil painting, glazing, except I do that I do it with ink. Yeah, and then it's like a multi-step, it's like a lot of processes that go on. It's like graphic design, layer building, printing, and painting all combined.
Wow.
Okay. Yeah, I know. So yeah, there's a lot of work that goes into them. But they do come out, in my opinion, rather nice. So I think I went a little dark on some of my lower layers. So I'm gonna lighten up the background a little bit over here, and then I think it's perfect. But this portrait doesn't exist. This was a lot of work because I do not use AI to do this. This is all manual work.
Nice.
Yep. No
Dude,
way.
I absolutely love that, Joe.
Thank you.
The depth in it. You know what I mean? It's just do that. You can't look away from that.
Actually, if you want to see, I'll show you one more, but it's not Tesla. But if you want to talk about the depth of it, I'll show you this, because this was the test of my process. Let's see,
real quick, I just want to say, Darren, thank you again, man. $10 super sticker, man. Thank you very much, brother. Taking care of us here. We're gonna have to get Joe to send you one of these, no problem, man.
Yeah. Oh yeah, Darren's on top of it, man. No problem.
Right on. Yeah, really, really like that, man.
Well, I don't know where I put the one that I wanted to show you, but I'll show you another one.
Okay. Man, this StreamYard screwing with my stuff again, man. Oh, I so hate this.
Here, I'll show you all. There we go. I found it. It was behind some other stuff. So all these are original designs and original works that I did. But this is my own process that I've been developing over years now. So you want to talk about like three-dimensional. How's that?
That's cool.
That is, right?
Yeah, that is crazy because, okay. Hold on. I'm looking more in depth in it. Yeah, because their face looks like it's coming out more than the body. And yeah.
Yeah, and if I
that's
shift
awesome.
it, you could even see. But yeah, I've got, see, like on this. And you could like see like the texture in this. And that's how fine it is. And yeah, then I have these couple. These are a pair that I did. And I really like this design. Yeah, that's
Oh,
just
nice.
straight up my art. It's part of the series that I'm doing.
Oh, that's cool, Joe.
Yeah. But anyway, that's that's kind of the art process and how I've been working on it. But the Tesla print is done exactly the same way as those. You know, and it's about 30 layers of printing ink, vice versa. But it's a whole entire process. So I'm going back and forth between digital layering and then going back and inking and then throwing it back through a printer to get more layers. Then you can't do that forever. So then it ends up being manual transfer, like of ink, like where I have to basically get the layer to like trace out, you know, on it, and then go back and then paint it and then do it some more. And then
Really?
I top coat it with like a really nice you know, like acrylic top coat. So it's like, you know, nice and sealed and matte, and everything that I'm using is all pigments. It's archival grade, you know, it's on cotton, cold press paper, and India ink and pigment ink. So
Gee, that's so awesome. I'd be completely clueless on how to do that, Joe.
yeah, I mean, not for anything. The artists are totally clueless on how to accomplish this. Like I came across something. I took things that I knew from all different areas of life and I
Uh-huh.
combined them into my art process over years. And then recently I kind of stepped it up and dedicated myself to, rather than just like doing constant experimentation, you know, actually like lock down a process. And, you know, yeah, it's still a little trial and error,
Mm-hmm.
but I think that it's pretty much found its, you know, it's found its own way. So yeah. So case in point is this nicely framed. I actually sent Nathan a picture of the mock-up. I don't know if he has
Mm-hmm.
that available, but we can show you that. I'm gonna do 25 signed copies. And you know, I'd like to see $150 a copy framed, you know, and you know, we could do shipping in the United States, and if it's international shipping, just get paid the difference. So, you know, anybody that's interested, Nathan will put it up next to his Tesla coils or wherever he has his ability to put that up, and you know, I'll have a few of them ready to go. So if you guys order, you know, you won't be waiting too long for 'em.
So as soon as you have your final design, just send it to me, and then what I'll do is I'll put it up on
Mhm.
my um, Shopify account, which is right up under the, the screen there that shows you
Mhm.
all the Tesla coils and stuff. I'll put it up right there, and then they'll be able to purchase it right
Perfect.
through
So
there.
yeah, and then we'll mention it, and when I have one that's done, you know, I'll show it again and everything, and you know, but that's more or less what it is. Portrait of Tesla next to a huge bifilar coil, and then it's got the flower of life, and the triangle and the Rodin spiral.
It looks like you put an alpha
over.
omega in there.
Well, it is in there because we know that's where it comes from. Right? We found that one, but
I see the 369 in there too.
yeah, well, that's what I'm saying. It's the 369, the triangle, flower of life, Star of David, and it's superimposed atop the bifilar coil. And again, this portrait of Tesla doesn't exist. Otherwise, this is a creation. So it is based off of the one, portrait of him sitting half in a chair. Okay, so there was a lot of making things happen, to try to be genuine to that original portrait while expanding it to something that's it's the entire man instead of just like this.
Nice.
So yeah, if you guys are into that, I hope you are. I'd love to send you a piece of my art and support the channel in doing so. And much appreciated. Thanks for checking it out in the first place. I love showing it off. It was like a big thing that I was looking forward to doing, and like I was very proud about it. I was like, yeah, I out of all the dumb crap that I do, I could do a Tesla piece, can't I? So
yeah, that's awesome, brother. I'm looking forward to those going out, man. People are really gonna like those. So
excellent.
I'm all good with that. Nice. So we'll lock down the details as soon as Joe's ready, man. I'll put those up, and then we'll put it out on the show that they're out there. Totally awesome, man. I can't wait for people to get that because the depth in there, you know what I mean? That's awesome.
Oh yeah, and it's gonna look real nice. I mean, again, if you find that picture of the mock-up, show it because it's nice. It's like black. It's got a black mat around it, and then it's gonna have a silver Tesla like signature like under it. So it's very decorative. It's gonna be one of those things that you could take right out of the box, put right into the wall in your office or wherever you enjoy it. Anybody that likes Tesla is gonna like stop in their tracks and when they see it, like guaranteed. So
there we go, right there.
yeah, there it is. So it's a pretty big piece as it is. So framed, it's gonna be nice. It's gonna be something to put on the wall. It's not gonna be a dinky little thing. So
what's your dimensions on that, Joe? With the frame.
So with the frame, I didn't have that exact frame yet to say, but it's about 6 inches bigger tall wise than this is, and this is 14.
So maybe a 12 by 8, 12 by 6.
Or no. So it's 14. So it would be like 20 tall, 20 inches tall, and probably about 12 wide. So like 12 by 20, something like that.
Nice. Okay, so it's a fairly decent size, like half a poster.
That's what I'm saying. Yeah. It's something to like put on your wall. It's like a nice size. I mean, I got a big old hand. My hand's not covering the whole thing.
Oh yeah. That is true.
Mm-hmm.
Oh yeah, that'd be awesome. Hang that up in my garage. Get me one.
Right on.
I'll have it right in here, man. I love Tesla.
Yeah, I know you do.
Right on. So what else you got going on, Joe?
Really, that's about it. Just quiet. Just grinding away. Between work and the holidays, and figuring out my art process. Spent a lot of time doing that crap.
Yeah, I'm there with you, man. I haven't had a lot of time through the holidays, man. A lot of family stuff going on. I'm excited, Joe, as soon as this weather cracks, man. If
Yeah.
I can get 2 hours out there tomorrow, okay, then I can wind my bifilar coil, okay, for my Bedini motor. So it's got to go on this, okay, which doesn't look too intimidating, but then you got to figure it's 7 wires plus a trigger wire, so there's 8 wires together. You got to run the length of 130 feet, okay? Again, not terribly difficult, just takes a little bit of time. hook it to one side on your drill while it's hooked to the other side over there on your fence, okay? And then run your drill and let it spin, okay? And as soon as it gets done, it's all tight and everything. So it's going to be just like the Rodin coil wire. It's real tight, okay? And I'll go out there with my camera. That's why I'm hoping the weather's good. I might have to go out there and have my son say, hey, if it gets bad, you need to cover my camera so I can just get it done. You know what I mean? And that way, or maybe I'll just put it under the awning cover. There you go. I'll put it on the awning cover. And then that way, Joe, I can get this bifilar thing worked out, because as soon as that's built, then I set my wood frame with my wheel to the size of it, and we move on to spacing, right? So I'll make it where I could take a plate underneath this coil here and raise it up and down where I want it. You know what I mean?
Mhm.
While it stays stationary to the top on the wheel that goes around here. I'm excited, man. I got all the parts of this thing, man, and I want to put it together as soon as I can and then get it running. So that what I decided to do with my channel is I'm just going to make one big build and like 45 minutes of in a video of everything and make it like plasma channel, you know what I mean? And just do a cool, awesome build. But then throw everything else in the member section so all the members get everything. The testing going to go through the growing pains of it, you know what I mean? The testing each circuit, the any behind the scenes information you wanted to know to put it together, stuff like that. All that goes to the member section, and I'll just leave the original video. And then I think that's going to be really good because our members take care of us on this channel. So, you know what I mean? They're going to get a whole lot of information on a Bedini circuit, that's for sure. And I'm
Yeah.
just going to go through it like I did with the Tesla coil and just piece by piece by piece tear it apart and see what's going on. You know what I mean? What the different things I can get done with it, how we fill capacitors with it. You know what I mean? Where we find the spikes, things that everybody wants to know up to date. You know what I mean? How do I do this? And then how do I ask the person who did it how to fix it? You know what I mean? If yours isn't exactly the same. So,
Oh,
Joe,
by the way, I forgot to tell you.
yeah, go ahead.
I figured out your gravity well situation and just how you make that work. I figured it out. I was like, because it was such a brain fart to figure out exactly how you get all these parts to move and not interfere with each other. But then I realized that the answer is actually quite simple, and it just simply has to do with bearings, right? So it's your center part, it's got to spin the one way. Well, that's not powered by anything. It's just a weight, and you use a ripcord, first of all, just to spin that one axis, right? Then your second axis you have that has a driven axle on two sides, okay? Now, the last one is the tricky one. You have to have it in two parts, okay, where it is connected only at 2 points, okay, and then that axle that drives the second wheel, okay, rotates 180 degrees, okay, in between the two parts.
Okay, hold on. We're talking about a different one. We're talking about Tesla coil inside of a Tesla coil, the round ones.
Mm-hmm.
Okay, and then just say where it goes again. We have a center rod that goes through the whole thing.
Right. Okay, so you have a center sphere that rotates, right? That's just a sphere part. Then you have your bolts, right? So you basically would have to have a rip cord to rip the center to get the one axis spinning, okay? Then you would have a second axis that's just an axle that would go to it and spin that entire one counter rotational of it, or 45 degrees rotational of it. Okay, so once you get that second one spinning, the trick is the third one, right? And how not to interfere with the axle of the second. And the answer is just to simply have it in two parts, okay, and have it ride on top of the axle. You see, so it would be like a slot, right? It would be like a slot that would the axle would be in between the two, where it would be able to rotate, but it would be able to rotate really only 180 degrees in either
Nice.
direction.
Give me a second. Just going over this.
So you'd have your sphere with your ring within a ring within a ring. You would have that. Then for your Tesla coil to induct into it, you wouldn't use any wires at all. You would just work it off of, as a transformer, like as through induction.
Mm-hmm. So what I'm just putting in my head real quick, Joe, is because you can't use a lot of metal in this. Okay, so everything in it has to be non-metal because it'll start sparking over to each other and just destroy itself.
So you use carbon fiber rods
Mhm.
for the drive points. You use ceramic bearing wheels, and
Okay.
you use 3D printed spheres. That's it.
Okay. That makes it.
There you go. All those are available parts. Or even if you could find small enough marbles, like that are not marble sized, you could actually use those as bearings. Those are glass.
Okay.
I mean, they're too big to be bearings for that purpose, but they kind of, if you made a channel for them, they could kind of work that way.
Nice.
Mhm.
You're gonna have to show me the direction again because the way
Yeah,
I have it set up, there's only one in and out point in the whole thing.
Yeah. I know carbon fiber is conductive, but when it's encapsulated in resin, it's kind of negligible, which is why even when they have, when they use it on like fighter planes and stuff like that, and they want to add a conductive element to it, God knows why they would want to add a conductive element to a stealth airplane. If it's not using any sort of electromagnetic, component to it, but they have to increase it by putting copper strands in it. And realistically, we all know that copper, yeah, it's the conductor we use, but it's not a great conductor. But that's what they use to amplify it is copper. So is it conductive? Yeah. But is it metal conductive? No. Like not in that context when it's embedded in resin.
Gotcha. I'm looking for the
Yeah.
picture that we had of. Man, you ever try to go back on this Facebook thing? Man, it takes a while to get to the right pictures. Sorry, I'm just looking for the coil so everybody could see what we're looking at. All right, go on, Joe. It's going to take me a minute to find this.
Well, Robert in the chat says if you could spin it, it will levitate. We tend to agree, but it's all about break the first. Getting even the second axis is difficult. Getting the third one is ruthless. So.
Well, the hardest one is the center one. Past that, I don't see an issue.
Well, but so all you have to. So for the center one is actually the easy one because you just have to do what everybody else would do in that case, like a top. All you got to do is use a ripcord. You don't have to power it. If it's I think the core of it can be metal. I think the core can be.
If the core is just solid sitting there and it moves versus the other fields, I'm good with that.
Yeah. So what you would do is, you would probably just get a tungsten ball, like a real deal fucking tungsten ball, and you would just how you would drill a hole in it. I have no idea. Maybe you don't get tungsten. You get a lead ball, or whatever the case is. Just get something heavy, and you put it on like a drill press if you have one. Unless if you have a lathe, I assume you don't. But just like get it so it's nice and balanced and stuff. Cut a groove in the middle, so you could use a ripcord. All you have to have is a hole, and then you drill 2 holes in the end so you could run an axle through it, and it's just gonna spin. That's it. Just like a flywheel. All it's acting like is a spherical flywheel. That's all you want for your core. And ripcord will do that. Look, if you use it on a ceramic bearing that's, you know, greased up proper and stuff, that thing will spin friggin' for a long time. You know, it'll spin for a long, long time. It'll also pitch to the magnetic north. You know, like the alignment again. Once you start spinning something like that, it wants to find that, you know, it
Well,
wants to find that angle.
it's gonna sit. Oh man, God, I wish I could find this picture easier. I wasn't expecting to talk about this Tesla coil today, but
Yeah, sorry. I know I brought this one up out of the blue.
no, it's all right. It's just I have so many pictures, man, and I sent. Hold on, here it is, right in front of my face, obviously. Okay, it's the different colors of it driving me nuts. Oh, and of course, this thing is not. You know what? I so am not happy with this. I'm going to send it to you again, Joe.
Right on.
I don't know why it's doing this. Sometimes, like when you get in here, man, and it won't let me pull things up all the time in this stupid thing, and I don't know why, and it's really pissing me off. So,
Yep. And Robert's saying that if you take a look at Hutchinson's stuff with the, you know, the metal that dematerialized, broke up, you know, he said that it looks like vortexes and that it's angular spin. That's the secret. I mean, I agree. You know, that's probably the best kept secret, because we could talk about electromagnetic fields all day, talk about gyroscopes all day, talk about all these different concepts, but they're all individually trying to achieve the same means to an end, but they have to be used in conjunction, like
okay,
to a certain degree.
I agree with that.
Yeah, at least in its configuration. Like, you don't necessarily need mechanical physical rotation, but you can't stymie your electromagnetic field from being able to fall into the proper angular momentum with the fields that it's working with or against. So,
Okay, well, this one was 2 Tesla coils running different angles on it.
mhm.
So up and down on the center one, and then left to right on the other one, and then the number one goes straight across the center. On the outside is a big ring, like it would be like a Saturn ring. Okay, but if you're saying that, uh, I could just make it an iron ball in the center. It wouldn't matter to me. You know what I mean? Just put it in an iron ball, and if you're telling me that it'll make it spin, I'll leave it alone, because the shaft on top and bottom, that's just there so I can wind it. That'll come out, and it'll just be this hole right here on top and bottom.
Yeah,
Okay.
because as soon as you put spinning mass in the middle, you instantaneously have gyroscopic angular momentum.
Okay. So we want the
All it takes is rotating a heavy mass on one axis, okay, to stabilize at least the second axis. Right. So now that the second axis is stabilized, that one needs to move. You know, and then that's kind of how it goes.
so you want it iron, or do you want it magnetic? Or
I mean, I don't know. I don't know if it matters or not so much. It probably, I mean, you would definitely get a different effect between if you used an iron core, a lead core, an aluminum core, which is very, very light, but you know, it would also push the energy out, wouldn't it?
yeah, well,
So,
that's what I'm asking. Which one you want?
why can't we just say all of them? So,
Because it doesn't work that way. I only
well,
get one shot
how
at
come,
it.
how come we can't have an iron core, you know, that's coated in aluminum? How come? I, you know, like best of both worlds thing. By the way, there's a 3D filament that I saw that is a dielectric medium. Like, that was pretty cool. It's very, very hard to print, evidently.
Hmm.
NASA uses it. You need 450 Celsius. And
Oh,
there's only one printer right now that does that, evidently. So,
so
yeah.
in this, I haven't placed the inside the outside. So is the spin direction good or is it bad for what this? I mean, I looked at it as the way we looked at the fields going. The magnetic field went up and down, so it bows out, right? Just like that. And then the outside field, it keeps it in. So it's more like an eddy current line. You know what I mean? So,
Yeah, I mean, we talk about counter rotational all the time being like something magical, right? But what's interesting about it is what I had said previously. I proposed. Like, I don't know this, but I think that since the angular momentum and the relationship to the poles and the fields is so significant, okay, that spinning with the direction, okay, that speeds things up. And it's probably an easier threshold to cross, speeding things up than slowing things down is, right? To be able to reach the magic threshold of breaking locality. So you probably want it spinning with the field, I would assume. But then again, that's why things are reversible. You change the plus and the minus this way, and then it goes the other way. So you kind
okay.
of got me.
I'm trying to wrap it into what I'm doing here. So I think I'm just going to wrap this the way that it is and thin out the area in between so they're equal in between
Mhm.
and run it like an orange. I just go up one side and back down the other, and up one side and back down the other, all the way around, and then continue to wrap it again. You know what I mean? And
Cool.
again and again, and then epoxy it and call it a day, and then run the rod through it and see what energy comes out of it.
I'd be interested.
So then you got two fields there, and we just run a number one on the outside. But I like the number one in the fact that we go like this with it because then we
So the
could test.
so the question becomes, right? If you run one that's wrapped horizontally, and then the other that's situated vertically, right, for your wraps. Well, the offset of that is 45, right? So is the field interaction then going to be just at the 45? I propose it would be. But then what
Well,
happens if you just put it at the 45? You
not if
know,
the number one moves left and right. It goes up and down like this. Then you're creating the other two angles that you need.
yeah, if it's pivoting, yeah, then it's self-adjustable. I like that. But I'm talking about the sum of the two four spheres of the secondaries. Their offset would be 45. If you go 90 on the field
Mm-hmm.
interaction, they cross
Yeah,
at the 45. That's what we've been saying all along. When the two fields meet, they cross at the 45. But these
yeah.
aren't parallel. They're inverse. That's interesting. I'm happy to know what this does when it happens.
It's just something to play with. You know what I mean? Because we'll probably learn something very specific out of the first one and have to build it again. Just have a feeling. So, and the less that rotates, the better it is. I'll be honest with you. Let the wire rotate it. You know what I mean? Instead of manual rotation, it would make my life a whole lot easier because then I could put it in any configuration or angle I want.
Right on.
Let's see if you're building to create one field built and two rotations, it'll fail. Well, we'll see. I don't think I've seen anybody do it. I mean, that's kind of the thing, isn't it? Oh well, we'll have to give it a try, man. But that'd be something I'll be working on for a while behind the scenes. Just having a little fun with it. Requires three separate fields. Well, I'm not arguing three separate fields.
Mm-hmm.
Uh, I,
And
what
then
I'm
and then the one. combined of all of them. You got to remember that.
Well,
How
yeah,
it's gonna work.
we're looking for effect out of it. Yeah. So I'm only running the number one on it and turning that on. I'm not putting any more power into it than that. You know what I mean? It literally is turn on the number one coil that's the rings on the outside and see what happens to the other two coils. I know pretty much what's going to happen to the round coil on the outside, but I don't know what the other angle is going to do to it. It may do nothing. It may do something. Who knows?
There's only one way to find out. Hopefully, not frying it and finding out. Just
Oh,
finding
yeah.
out.
What? And the thing is, you don't want them to combine. That's kind of the point. You want them to layer. You know what I mean? You want the energy to layer. You don't want it to combine. So, yeah. It says definitely do something.
For real. The best setter. Happy New Year's, brother.
Wouldn't be the first time I fried something.
It'll do something. I love it.
I haven't heard a capacitor sing while charging it at all, Victor. To be honest with you. Yeah, store energy through crystals. Yeah, seen that
Mhm.
one.
Yeah, next week when I'm on, I'll bring some of those unseen quartz videos.
Right on.
I'll
Yeah,
try
I'd
to
like
edit together like a little greatest hits or something and shoot it to you ahead of time so we can take a look at it. But yeah, there was some fun stuff that I saw with the crystals, man.
Yeah, and then hopefully by then I'll be able to fix my StreamYard and get rid of this big ass bubble shit that runs across the screen where you can't see half people's faces so you turn it on. Fucking frustrates the living goddamn hell out of me that they keep changing this shit and altering
Yeah,
it.
whatever
I
happened
just,
today, I was like, where am I?
yeah, I'm just like, fucking leave it
I'm
alone,
on, but I
man.
don't see. I don't see.
Yeah, I don't want your fucking updates. Just leave it the fuck alone. You know what I mean? God, you want to frustrate me? Just do that. It just drives me nuts, dude. Ah, I like things to work in a certain way and consistently, and this drives me up the wall. So, anyway, whatever. I'm sure Bernie will pop in, fix it, and then turn off my stream.
Probably. Speaking of the devil, he's coming your way shortly, isn't he?
Oh, on the 15th. So we'll see what goes on there, man. That's what he said. So I don't know if he's gonna pop in here first or somewhere else. We'll find out. You know, be closer
Well,
to the day.
hopefully TSA doesn't take his wallet again. That was a mess. Bernie's live from the airport. Can anybody Venmo me a couple dollars for a sandwich? It's like, oh, Bernie. That's rough.
I'm gonna have to drive the wife's car up there and pick him up, probably. So I hope it's not
Very
at
cool.
night, man, because he's gonna be driving home at that point. Because I don't like driving at night. So yeah, that'd be fun though, man. Because what we're doing, Joe, is we're setting up. Give me a bunch of ball jars. I'm gonna go out and pick up tomorrow. And he's gonna set up his electroculture on the wall behind me or in front of me, I should say. And we're just gonna run it. Bunch of little 5-volt electrocultures out there doing a bunch of stuff. And I'm hoping some turn into paste where we can get it on there, because two things I always wanted to do on that stuff: paste it out on top of a surface, and then take high voltage and run it right across the paste like this.
Mm,
I want to see if it structures in there. You know what I mean?
yeah.
That's kind of one of the things I wanted to do. And then I wanted to put it on some kind of a plate thing where if it's on there and then you hit the voltage onto that plate, if it actually will structure that way. You know what I mean? Just instantaneously.
Mhm.
The last thing I wanted to do is put it into a capacitive field, okay, and see what happens. And just, you know what I mean? Try to put it in like a little bubble zone so we don't splatter everybody with it. But I want to see how it interacts with the high voltage that way.
Oh, what I want to see you do is I want to see you um run a cathode through the material that's in there. And then run a RAV. That's what I want to see.
Oh, yeah. There you go. Absolutely.
You know, see, that would create all sorts of different ionization, and you damn well know what the RAV is doing. So
Well,
See if
yeah,
see if it's what restructures it. See, like once you have the broken pieces and they're just there, see if it's accumulating and how it's accumulating and what comes out the other end.
see if it builds a structure inside of there with the water in it. Yeah.
Wouldn't it be cool if you like turned it on and you thought of a television or something like that, and then you turn the thing off and there's like a very miniature television, but it's like it even says like Samsung on it. You know what I mean?
That'd be
It's like
awesome.
we did it.
Oh, so much better than my shit experiment. Yeah, that would be awesome.
Yeah, or like a little gold nugget or something.
I got to see because some of the stuff he says is very bad to get on your skin. So I got to take notes. You know what I mean? Make sure I don't have any of that near me because that would be very bad. So
Yeah, make sure that you ask very precise questions, and if he starts to go off, be like, before you go there, yes or no.
yes.
And then to write it down, and then be like, okay, continue.
Oh, you bet your butt, man. I'm gonna have me a little flip chart that I wrote everything on. You know what I mean? To check it and where
I
each
love
one
that
is.
guy, but I know how a good conversation goes with it. But it's like, man, we talked about everything except for what we set out to talk. We danced around that one for a good minute.
Oh my god. Yeah, we'll have to put tape and stickers on it and everything else to identify everything. It's
So
just gonna be fun, man. Because yeah, we got a lot of experiments going on here, and I've been waiting for him to get here to show them. You know what I mean? And it's just gonna be fun putting them all out, man.
yeah, this is great, and this is the first major in-person Old Man Builds collaboration. We're coming up on 10,000 subs. That's huge growth for the year, man. I'm so proud of everything that you've accomplished. Really.
Well, right on, man. I don't do it without any of you guys, man. It's
No, I mean, that's true, but you put in the time, you put in the money, you put in the experiments, so that's what it's about.
yeah, right on. Thank you for that, Joe. Yeah,
Of course.
500 more subs, man, and we're at 10. And then, what do you think the prediction is for this year? Then think we'll
I don't
do
know.
another. Think we'll do another 10, or we won't get that lucky. I'm hoping for 10.
I feel like it works off of thresholds, and as soon as you cross certain thresholds, you gain more exposure. So I think 10 is one of those thresholds. I feel like once you get to 10, then you get a bump in the algorithm, and then at 50, you probably get a bump in the algorithm. It's every time, it's always a stretch to get to that next threshold where you get more exposure,
Mm-hmm.
I would say. But I think that 10 is definitely not only a major accomplishment, but I think is also a significant threshold as far as YouTube is concerned.
Okay, sounds good. I hope it is. I hope you're 100% right because it'd be nice to get a boost after that. But I've been trying to perfect my craft behind the scenes and getting stuff right. So yeah,
Yep.
I'm waiting for some mics to come in, Joe. I got them coming in today because my mic went bad.
No
So
kidding.
yeah,
Your
so
audio sounds good for what it's worth.
well this one, yeah, but not the one where I do the videos. So
Uh,
I got this whole background set up and everything, and you know what I mean, ready to go, and I'm waiting on that. And then we got to get that logo, Joe. I need to get that from you so I can set up everything for the RAV. You know what I mean?
mhm.
Because I want to get started on that right away. You know what I mean? Once I get the mics in, man, then I can get my parts nailed down and you know what I mean? Get it
Yep,
off to
yep.
you.
We could get together, start scripting. That's exciting stuff. And for those of you that don't know, Nathan and I are going to be creating a new channel that's you know no real lives or anything like that. It's all going to be kind of more an episode format. Try to make it entertaining, like sort of like a history channel sort of thing, more than you know you know, a whiteboard explanation or a live where we're just rambling, going all over the place. Like, what we're going to set out, tell the story, show the lab work, kind of,
Hmm.
you know, if there's any drama, we'll make sure that gets in there to keep the suspense real. Like, you know, try to make it like a real show.
Yeah.
You know, I might even have the guy from Ancient Aliens like uh, do the narration for it, like the crazy dude that doesn't that the you know with the hair
Oh God.
or something. Someone good's gonna you know, narrate that. That's all I'm gonna say.
Yeah. No. Go ahead and tell them what it's called, Joe.
So what did we settle on? I
Huh?
forget. Plasma, poop, plasma, 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 plasma.
Plasma Unleashed.
Oh yeah, plasma unleashed. That's it.
Oh
Plasma
man,
unleashed.
that's so great. I love it. No, I have a little fun with each other, man. Come up with all these things, go back and forth so many times, it's unreal. But yeah, it's
For
really
real.
good, man.
Yeah.
I'm excited about it. I think Sean's excited about it too. He keeps talking to me and telling me and stuff like that. You know what I mean? When I talk to him, it basically just shows all of his work. You know what I mean? And how far it can be pushed. And man, some of this stuff is wild, man. Some of the other stuff that he's doing, and it's going to be good because we got enough material for a whole year, a whole season. You know what
Oh
I mean
yeah, we
already?
definitely have a season's worth of work, and then you know, at the end of the day, like everything that's happening now will just be next season, so to speak. You know, and
Yeah,
try to get like a good 10 episodes out there, kind of quick, tell the story from start to finish, and you know, then it'll kind of be up to speed of now. Except by the time that's done, we'll have done a whole bunch. We'll have a whole new story to tell. It's sort of like Oak Island.
yeah, kind of like
It's like,
that.
yeah, we didn't find the chest, but we found things that indicate the chest, like every other season.
They drove me nuts, dude. I think I stopped at the eighth season of that one.
Well, it's like, but ask Ashton Forbes. You know, can you ever find the chest? No, you can't ever find the chest. Don't ever find the chest because then you don't have a show.
Yeah,
That's how it goes. Yeah,
that's funny. No,
yeah,
I think it's gonna change people's minds on a whole lot of things because
I think so.
there's there's going into it on a very safe. This is plasma physics basic thing that they see, and then there's let's go into the woo and just fry your mind with everything that we see from around everywhere with hieroglyphs, and you'll be like, what the f is going on here? Like,
Hmm.
is it really that true? That's what I think. That's my favorite part of it. Okay, don't get me wrong. So, just so you know, I break my own rules. One, I'm going to use ChatGPT, and two, I'm going to use it to give you all of the actual math that goes along with everything. So at least you'll have it, and we'll straighten out everything that I do in that way, and I'll
Oh, it's
start
good at
saying things.
formulas. It's good at formulas. It really
Yeah,
is.
it'll start saying things with the correct verbiage. You know what I mean? Here's the A field, here's the B field, here's the E field. You know what I mean? That's one of the things I've been trying to incorporate into my videos and stuff like that. But you know what I mean? I'm not perfect right off the bat, so we'll be straightening that out a bit, but it'll help everybody. So we won't get away from the fact that it's understandable. I will not be that boring guy sitting in the chair blabbing for 10 minutes that puts Nathan to sleep because I cannot do that. I can't even put out the words to put myself to sleep that way because I'll be asleep in the first 10 minutes just trying it. I've tried it. It doesn't work.
Yeah,
So
we're gonna be like the experts with the names underneath.
gotta get lab coats like Ben. We got, you know what I mean? Show up on our lab coats on a little tie. You know what I mean? And then look real professional. And then you know what I mean, have nice done hair.
You know, I should be like the Guy Fieri of physics, right?
You gotta
I should
dye
like
your hair all
bleach
white.
my hair and blow it out and have like a lab coat with like 50s like retro flames on it.
Just shows up in his Camaro every time. Hey, Oh, that'd be awesome.
This week on Plasma Unleashed.
I love it. Oh, I love it. Oh, we'll have to get ourselves a physicist to tell us everything. You know what I mean? Sound real professional. You know what I mean?
Yeah,
That's
that's
funny.
good.
Because you know that's what's
Ridiculous.
going to happen after like the 5th episode. Somebody's going to get pissed and go, "All right, you clowns, I'm going to straighten you out." You know what I mean?
Mhm. But
That's
please, they should sit there and get on a video thing and just write a little narrative naysaying us and have their own little segment, and then we'll just include it, and then we'll tear them to shreds, and they'll have no input. It's
well, dude. It would be better if they worked with us. You know what I mean?
chorus, of course.
But I don't want to crap on anybody. That's for sure. That's not what I want to do here.
No. It's not about
It's-
crapping on anybody.
Oh, I love it. Yeah, Sean's going to be the science guy. That's going to be awesome. So they get Sean to do like a 5-minute segment on it. You know what I mean? You can talk about how he created it real quick. I love that part, man. That would be awesome. Oh man, you need a fireplace? Oh my god, no.
Yo, see, that's what I was thinking. I'm dead ass serious. I was gonna sit in like a fancy chair and be like,
You're
like a
gonna
bunch
put
of
on the cross sweater. You know what I mean? The nice sweater,
that
the little
even.
V.
Yeah, no. You'd like make like I have a whole bunch of like what do you call it? Vinyl crocodile skin material that I've had sitting around for like 3 years. I'll make like a plaid, not plaid, a patent, crocodile skin suit jacket. How's that? And a bow
Oh,
tie.
man.
Everybody
Oh my
knows that
god.
every good physicist needs a bow tie.
You know, be half physics guy, half crocodile hunter.
That's it. Yeah, right on.
Oh, that's amazing.
Crocodile Dundee hat, Awesome.
Oh my god, dude, that's so hilarious. No, make it real professional on that one. I'll be honest with you. That's what
No,
you're
it's going to be good, but it should be entertaining as well. I think that hitting that mark where it's entertaining, engaging, a story, but using the right words and stuff.
Mhm.
I think that's the recipe to appeal to everybody. Really, people just coming into it that are just following the story, learning a little thing or two. People that are into it, and they're critiquing the work, like that whole exactly dead on. This is what I'm talking about. Right, buy a fire in a bookshelf. Like that's exactly what I had pictured in my head. So me and Darren, same page. But anyway,
Sharp dressed man. That's
yeah.
that's our theme
down,
song.
down, down. Anyway,
Oh,
digress.
wow. That's hilarious. You see Joe breakdancing at the end, every time.
Yeah, maybe 10 years ago. My shoulder hasn't been feeling too hot today. I'm like, oh. What'd you do? I woke up.
You're getting old at that point, huh?
Yeah, right. Oh, you hurt your shoulder. What'd you do? Yeah, I woke up. I slept on it wrong. What do you want?
Oh man, yeah, dude, this is gonna be epic, dude. I need to get my mic, get my lines down, get it set up with the logo in the back, and get it to Joe as fast as I can, so that I mean, he can point the direction for the next part of it. You know what I mean? And then make sure that our analysis is all on the same line. You know what I mean? No contradiction or anything. We just get it. You know what I mean? Figured out, and Joe approaches it a different way than I do. And then if we can get Sean to pop in, you know what I mean, and approach it his way, I think that's gonna be cool. You know what I mean? Even if he's only popping in every once in a while, I think, dude, we're good to go.
It's just all about the little pop-ins, just like the History Channel.
Yeah.
Because the narrative is the story. That's like kind of what's telling the story. That's kind of what's explaining it. It's like we show up, we're just like it's like answering a question that wasn't asked. It's like or sharing the story or the experience or whatever that we have.
Yeah, yeah. No, I agree, Joe. I think it's going to be great, man.
I think it's on point, man. It's going to be real good.
Yeah. So can't wait to get that one going, man. I'm excited. Still getting stuff in from the holiday, man, and because I ordered a bunch of stuff, Joe. Let me just tell you, I spent all my holiday
Nice.
money on my channel. My wife looks at me like I'm a crazy old man. You know what I mean? What else are you gonna buy? She sees all this stuff showing up. Oh, there's 10 pounds of wire. It must be Nathan. You know what I mean? Like, oh, these little needle things in for your testicle. Oh, another Nathan thing. She's like, what the? You know what I mean? And there's like 40 packages that arrived for me, I think, in this last week. Because I told her, I says, I'm done. I have everything. I'm gonna build it, and I don't care. So you guys are all gonna have to just leave me alone. I'm gonna end up locking my door on the outside and just put a sign that says on air. Leave me the F alone.
It would be interesting to know what your wife thinks about this and tells her friends. Like that's the interesting thing, to be a fly on the wall. It's like, yeah, he's got this YouTube channel. I don't know, some mad science stuff. I have no idea. All I know is there's packages that come all day long, and and he's got 10,000 people that regularly watch him.
Oh my god, dude. Yeah, so yeah, she thought it was hilarious the first time I told her I had my own song to my show, you know what I mean? Or you know what I mean? We did little videos and stuff like that with you and I, and she's just like, "Oh my god, what is this guy gonna do next?" Right? And she sees all the stuff, and I keep showing her. I go, come on, take a look, take a look, take a look, look. It shoots 13-inch lightning bolts out of the top of it, and she's like, "What the?" And then my daughter's like, "I'm never coming in here again, Dad." Yeah. They all stay away from my garage and like pop their head in, like, "Is there anything blowing up in there?" You know what I mean? Yeah, I had to get a fire extinguisher because the wife wouldn't let me do any more experiments without it.
He
So
does understand that the
yes,
types of malfunctions that would occur that would be absolutely futile. It's like,
well,
how do I
I
put
thought,
out a dematerializing black hole? Like what? Pump a bunch of like compressed CO2 into it? Like probably. Maybe that
so
does work.
I made the mistake of showing her. I was going, "Look at all this high voltage, right?" And then the frame of it was wood because I didn't want it to be metal. And the thing set on fire, and she's like, "Oh my god!" Ball of flames goes up, and I got like 5 different voltages going in there. You know what I mean? Different angles, dude. Oh yeah, that
It's all
didn't
right.
go over
I've had
well.
people over and I put the Tesla coil on and I'm like, oh, check this out. They're like, I feel sick as soon as you put it on. And I'm like, oh yeah, that's because your chakras are out of alignment. I was like, don't worry, you'll get used to it. They're like, I have a pounding headache and I feel nauseous. I'm like, yeah, that's probably some radiation. It's no big. They're like, and what? I was like, yeah, just go outside with your shoes off. They're like, what? Like,
So
what?
hold on, Joe. This is what my son got me. He goes, "Okay, Dad, we don't want to die in here." So he goes, "Here's your radiation detector. Okay, nuclear radiation detector."
Mike, you should test your old tests, dude. The ones that were like really bad and chucking the goods.
Oh yeah. So I think he just wanted to know for personal reasons whether he needed to cover his goods. You know what I mean?
So, a self-serving gift, huh?
Oh my god.
Next year for Christmas, you got to wait the whole entire year, though. All right, but you got to buy him a lead vest. Be like, oh, this was in response to me finding out about all the radiation.
I get him some lead underwear instead. Protect what matters.
There you go.
Oh my god. Yeah. So that I just thought it was awesome. I told him, I go, I don't have one of these. And he goes, you don't? And what are you doing? He goes, Dad, that sounds bad. And I go, well, yeah, a little bit. So I want to test. Okay, remember we're doing the light bulbs with the 2 coils?
Mhm.
And that's the one I want to test. That one, and then the Ravs that were just blowing up everywhere.
Oh yeah, the wraps with the yeah. That might perk up. It might. It might not too though. It might not. Like it could go either way. You know,
50
because you want
shot.
to know something. When they leak, we don't know what they're leaking to. It might not be as ambient as you think. You see, there's that whole other side of it because it's so coherent and it blasts out like a laser and it has a definite terminus. You know, it doesn't. It won't flash onto the wall. Let's put it that way. The wall's far away. It's not going to flash onto the wall, no matter how bright it is. It's got a terminus. So that discharge, that radioactive potential, this potentially radioactive discharge, right? That might actually be feeding the other loops. So
There you go.
you know,
Right here.
you got to bear that in mind. And there's, you know, it's no different than the what do they call that, Tyson model or whatever effect that you get from the flare, right? And we know that it now feeds the RAV. How the hell does it do that if not for that type of radiation? Yeah. So
Yeah, there you go. Blasting gamma is what we want to know for sure.
And that is what we want to know. And I have suspicions on a couple of experiments.
Yeah. Well, we're gonna find out. You know what I did find though, Joe? Remember I showed you the plate thing a while back and they pull apart and stuff like that? They make one for science. So it wasn't just the guys one off. They actually make one, and I found one.
Oh, that's cool.
For sale. So I put a bid on it. We'll see if I get it. And
nice.
It's 2 round plates, and then it has a spot where you can put something in the center, like a little clip-in thing, and then you could put like a shield in there or whatever. My thought was we'll see how that asymmetrical capacitor works on different distances and what it's actually doing. And then we put a center plate in and see how it's working. So we don't have to start up this whole big device, you know what I mean, over here. Like just do it in simple fields and see what's actually going on. That I'm excited about. So I'm kind of hoping
getting some. The fact that you don't have any like of that magnetism paper yet is insane to be able to like visualize what's going on where. So, you know, like that. I don't even think that's expensive or hard to get. I think you just have to.
Cheap.
Right, I think you have to do it. You just get like a big sheet of it like this, and you could kind of walk up the stuff and, you know, look around and see what the geometries look like. Give you a much better idea.
Yeah. I guess you're right. We'll just have to get some.
By the way, one thing I've been noticing on that subject, okay, is that if you slow down any of these RAV experiments, you could see the convection events occurring. It screws with the, I want to say, air. It messes with the way that the sensor picks up the ambient area. So any background or anything like that, you'll see the motion and the flow patterns of certain things, like quite a bit. Now, we've seen it obviously in a handful of things where it looks like the Sahara rising, like heat and stuff. These things aren't hot. You know, you got to realize that. So there's excitation events that you could actually see if you look close enough and you play with the levels, because they get hidden by the levels. Because there is always a certain amount of like grain drift in sensors, just generally, that'll give some kind of perception of motion. But if you blow that out, you could still see it. So if you take any old video and you blow out that grain, it's gone. You know, if you do the same with these experiments, you'll see it doesn't go away. So, and that's pretty interesting to see that, because it literally looks like particles moving. It's like the laser dancing effect. You know how it looks like it's dancing and twinkling?
Oh, yeah.
Kind of. The same sort of deal.
Huh.
is going
Hey,
on right around these experiments all the time.
we're gonna have to shoot a laser into this thing, Joe. The only laser
Yeah,
I got is a
all
little.
these things are like, these are all things we got to do.
I got a little cat laser. I don't have one more better than that.
Yeah,
Will
I
that show
need. I
anything?
don't know that that's going to do it.
What do you think? Like 1,000 watts, something like that? I don't know.
You're going to want something a little powerful, but I think just as important as anything is the wavelength. Because
Okay.
remember, they're lasers. It's a specific wavelength. And what I'm noticing is that the energy side is all UV spectrum stuff. Once it starts to fall to matter, it goes redshift. It's redshift, blue shift. So you go into that UV spectrum,
So you're saying getting
you
the
know,
red and the blue one?
get a blue one.
Okay.
Yeah, blue one, purple one.
Put it on my list.
Yeah. Some of them are like really burny lasers, you know what I mean? Like you got to watch out for that.
Which well, what's how big of a laser do we want then?
Like I said, I think the wavelength is just as significant as the output. Obviously, you'd want a good high output because you want a high energy density.
So that's what I'm saying. I have no idea what it is. Is it
Well, you
500
got to
watts?
research it a
Is it
little bit. I mean, I know a thing or two about it, but not enough to like talk fluently about it. So I'd be saying like, incorrect things if I were to go into more detail.
not a problem? I'll
Yeah,
research it then. Yeah.
yeah, research it.
Hmm. Just
Yeah, go
curious.
check out Styropyro, yo. He's got some good laser shit going on. He always does.
Oh yeah, yeah. Yeah, I'm gonna have to check that out because it's just something interesting. It's because of the light in the way it's working and everything like that that would draw you into it. I see exactly where Sean was going. So he
Hmm.
says 250 watts to 1,000 watts vat, blue or infrared. Cool.
There you go. He knows more than I do, and I don't know who that is. So there you go. You know what I mean?
It
But
sounds
yeah, no,
good.
I mean, all I knew was you're going to want to stay away from the middle spectrum because I don't think there's a lot happening there. So you're going to either want to go red or blue or purple, in those ranges. And I'm pretty sure that the blue shifting has more to do with high energy density, and the red shifting has more to do with the matter spectrum. Red is in association with matter, whereas blue is to energy.
Well, see, I, maybe I should clarify what I want to do with it. I don't want to cut anything in half. I simply want to see if it reflects, absorbs, or what it does. You know what I mean?
Well, then you might maybe if you want to just see what the coherent light does, and that's the purpose of the laser, just get low power, cheap, cheaper lasers in a variety of wavelengths. And
Okay.
I think cheaper because there's going to be certain wavelengths that are very inexpensive, and then there's going to be certain wavelengths that even at low power are, you know, potentially prohibitively expensive. It's just a matter of how they're able to make that particular wavelength. Like I know that some yellows and oranges and stuff like that tend to be very expensive because they're almost impossible to make. And blues tend to be a lot more expensive because the materials are expensive.
Mm-hmm.
So
All right, we're gonna have to find out, Joe.
yeah,
It's just something
another thing to look
interesting.
into.
Yeah. Well, dude, this is gonna be my year. I'm telling you that right now. I got cool builds coming up, man. I'm excited about them, Joe. And to be honest with you, kind of clearing the plate of anything else and just doing that. You know what I mean? Doing the builds, doing our show, doing the builds, doing our show.
Mhm.
And then, what I mean? Our shows are going to here coincide with that or be something we can look up, you know what I mean? And be confident talking about within a day. But
Yep.
I'm going right into that mode, man. And damn doctor put me on a diet for all the stuff that I got going on. So, I'm going to be feeling it and shrinking throughout the year. So,
Nice.
I don't have a choice of sticking with it either, Joe. That's the thing that sucks. There's no
Yeah.
choice. That's what
Yeah.
he basically said. Yeah. Oh well.
Yeah. Hey, listen, we all have fun when we can. And I guess the good thing is that once you get to a certain point, then when you do get to eat things that you enjoy, you know what I mean? Like it'll be meaningful, right?
There you go.
You have what you want all the time, then it kind of loses value anyway. So you take the good out of it,
Yeah, I guess.
not the bad. I
We'll
know,
see,
trust me,
huh?
I hear you. I'm going back on cabbage soup myself. So
Nice. Yeah, I like this cabbage soup, to be honest with you. It tastes real
yeah,
good.
yeah,
It's a good meal.
pretty damn tasty.
Yeah, I'm going back to, I mean, little container size, and whatever fits in that little container, that's it. So, yeah, about 1.5 inches high, 4 inches by 4 inches, man, and that's it. So if it fits in there,
Chocolate fudge. You could fit a lot of chocolate
not
fudge.
putting chocolate fudge in there, Joe. That's not the point here.
It's like heavy, like a lead brick of sugar. Then it's perfect.
No, no.
No,
Uh,
no high density, high calorie. That's
no.
not the deal.
Like
Oh,
mostly protein in there and greens. That's what I'm looking forward to.
that's good. I have a couple recipes I can share with you that I think you'll quite enjoy.
Yeah,
So
because it doesn't matter. Like if you put a little sauce in there or something, it doesn't get because there's not enough food there.
no, there's not enough volume.
Yeah,
Yeah.
it's like it's a snack, is what it is.
No,
Is
no,
you're
I
gonna
did a few things that when I was in a healthier, better stage of life, just generally, like that I would go to and eat, and it was satisfying on every level. So, it was good stuff. Like used to do like chopped salad with like hummus and tabbouleh in it with like olives and nuts and chicken, like just like all chopped up into like basically a mush mixed together with the hummus. And I know it sounds like a little weird and unappetizing, but it's literally delicious. And you have everything in there. There's like walnuts, with the hummus, the tabbouleh, you have all your fresh herbs, you get a little chicken. And usually I would do like a arugula and spinach for the greens. So, you're eating bitter greens.
mm,
Good stuff, man. Like you actually like live a long time and do some oil vinegar on top. You eat like that, you're going to live forever. Like there ain't nothing in there to kill you.
yeah. Oh man, that's gonna be good, Joe. Give me a second. I'm looking up something for Dennis right now.
Right on.
He did that SimScope. Remember that the Tesla coil that blew out my ears?
Mhm.
So hold on. He gave me a couple updates that I put on there. I don't know if everybody did them and put them in there. I'm trying to find the original when he sent it. Uh, I don't know. I'm gonna have to look this thing up. We're gonna have to show it on the next live. I got a long list of stuff in here. Anyway, basically, what it is a simulator for his Tesla coil, and he was able to put in all the different parameters where you can change the frequency and everything on this thing. And he wrote a couple updates for it.
Nice.
And yeah, so you'll be able to get that. And I have it on one of the videos a while back. I don't remember which one, or else I'll put it in the comments. I'll have to look through um, all my stuff on Patreon to find it. But yeah, I'll put it back up there for you, Dennis, and run it again. But yeah, it was cool, man. It was simulating the Tesla coil and the frequencies it was putting off. So yeah, it's got two updates since the last time he put it out there.
That's awesome. Yeah, no, it'd be great to hear exactly what the specifics on that are, and I'm even more excited to see that. See it in action.
Absolutely. Yeah, sorry, I have it. I just don't have it right away where I can pull it up right now.
Yeah, that's reasonable. We'll save it for next week. You can tell me what it is, and we can talk about it.
Yeah, well, we saw it once together, Joe.
Yeah.
Um, that's okay. I'll just find it and put it up the proper way. You're right. He said 3D scope frequencies now can use the mic. That's pretty cool.
Ah, okay, like that. I got you.
Yeah. I need to get a different mic. You know what I found out, Joe?
What's that?
Okay, so my hearing aids pick up a lot of different stuff from sounds, right? And ultrasound, stuff like that, that I didn't realize it did. But I found out that my phone has an app on it from when I got my hearing aids that I'm able to record the sound off of them. So I'll give you an insight. When I put an ultrasound onto an energy source, it'll scream like a banshee when you line it up. Okay. In my
Mm.
hearing aids. If I'm standing there, I can't hear anything. If anybody else is standing there, which is probably the better rule, they can't hear it. But as soon as you put in the hearing aids, you can hear it clear as day. So I thought to myself, okay, there must be a mic feature that it's showing that normal mics cancel out at that level. So I wanted to do a little more research into that and be able to find the mic so that people can align these things properly. Because that way you could do it by the sound of it, you know what I mean, when it lines up. And that means that in the part that Lightspeed's doing and doing all of that work to put everything in the computer like he is, it's going to be very helpful because you'll be able to align that properly. You know what I
Mhm.
mean? Where everybody else can't. So it'd be something interesting for that. So, and then I was looking at something else that you take your volts and amp meter and you'll be able to hook it up to the computer and just basically add a data source to it so that we can put it in there. So I think that's going to help. You know what I mean? So he may have a better way to do it, but I found a video on it on how to convert a cheap $10 volt and amp meter to give you those into a data source. So yeah, it's kind of interesting, man. I can't wait to, we get that set up. So, and he's got all the sensors set up already for the magnetic fields and everything. So
Very
we're going to
cool.
get a lot of data really fast, Joe, as long as everything works right.
The data is great, and just having more material for analysis generally would be awesome because like with the holidays and everything, things have been at a bit of a lull lately.
Yeah. Well, I'm excited. Okay. Somebody found a way, and I'm sure there's better ways, but I haven't seen them because every time I go looking for this thing, I can never find it. It drives me nuts. If you're pulling in information, right, to anything it is that you're monitoring, it has to come up on the screen, right? Therefore, it's putting data points to the screens, ones and zeros, in order to propagate your numbers, right? If that's the case, then you should be able to take that and put it into a data port and then put that right into your computer and have it read the ones and zeros in order to give you the information right offhand, right? And as long as you can make the program to accept that, then you should have all the information right in front of you. One of my goals is on all my experiments, I would love to have right at the bottom where I don't have to do anything, just like in 2 inch across the bottom, it says my volts, my amps, and my frequency on any one of the coils I do. So when people watch the video, they go, okay, you're running a Tesla coil, so what's the voltage, what's the amperage, and what's the frequency, right? Perfect. All right there across the bottom. That's what I'd love to have, just at every time. Sensor it right next to it, boom, 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 show it right there. See, that's like
Awesome.
that's a game changer, right?
Big time. I mean, the data capturing of the data and then, making sense of it and being able to capture it in a way that's able to be reviewed in general, or knowing where it's at, and then being able to make the adjustments and see what the adjustments specifically do. It's been the most elusive part of all this experimentation. It's where it's the difference between actually having a laboratory with equipment and not.
Yeah.
Like that's what it boils down to. Like that's these labs are labs for a reason. It's not just a glorified, more sanitary garage. Like
Well,
they have
yeah.
they have equipment. They have lab equipment.
Well, it's also once you get the data, you can 3D model it. Like
Yeah.
I remember I sent that modeling program to you right away. It does it just by going through the different ratios and stuff.
Hmm.
So what happens if you connect those two programs together, the modeling program versus the program that puts out the data? Then you automatically get a model of what you're working on. You
Hmm.
automatically get to see everything of what it's doing in real time. That's what I'm excited about, because then you can see fields and stuff, how it goes like this together, how they compress. That's got to be the most interesting thing. I would love to be able to set up something where we can take a volt and amp meter and get a small program together for people to run across the bottom of their screen, okay? Just like I said, and make it where it's like, hey, either you can follow along the instructions or Old Man Builds will resolder it for you and get you a data port. You know what I mean? And
Hmm.
get you so you can get in the game. You know what I mean? I think that would be awesome.
I think that'd be great. And that's the name of the game at this point. It's one thing to, see what you see, but to actually have like, more empirical evidence is, that's exactly where you take all your theory and stuff that we're talking about, but then you dump in your data from your experimentation, as the proof of the theory. And that's the missing link here. See, because we could talk nice and we could even have the math straight, and people would be like, "Great, so prove it."
Yeah.
And the things that we're doing, I feel like, inherently, especially with Rab, I think I think it's all there to be found and there to connect all the dots. So
So it's like what everybody always talks about. Hey, do you get a Raspberry Pi? Do you get an Arduino? Stuff like that. What's cost efficient? I mean, think about it. If you said to anybody out there, I can model it on your computer and have everything done, that's $1,000, right? Just put a price out there. There's a lot of people that be like, that's kind of expensive, but it shows me every bit of data in a lab experiment with every sensor I could find. I mean, I don't know if that's the right price point, not. I'm just saying it would be interesting. Or if you said, hey, you know what I mean? Here's this $10 part. I'm going to modify it for $20 for you. And there you go. You could be
yep.
able to put it on your computer. And they're like, that's bitching, dude. That's what I've been looking for the whole time. Because I'll be honest with you, Joe, I hate having to look for every different meter. And then I've even looked for meters that you see on TV programs that are like this. Okay. And I can't find them. Okay. Anywhere. And I go, okay, so what if it just propagated across the screen on the bottom? Then you'd be like, okay, now we're in it. Now we
Yep. No, right. That's exactly what you need. I mean, listen, here's the thing. Science has taken such a bad turn in the last half century because they went that direction with the colliders and shit. You see,
ugh,
once they started going that collider direction, they took all of the resources, putting it into that, and all the sensor technologies and putting it into that to find nothing productive. Nothing productive.
yeah.
And I think Sabine said it the other day. I think she said China had plans to build the world's largest new collider, much larger than CERN. I mean, it's China, for Christ's sakes. They could do that. They
Mm-hmm.
got plenty of land to do it, right? I mean, whatever. Eh, They literally said, you know what? Yeah, we're not gonna. And that's from the Chinese. The Chinese would build something like that just for the spectacle of saying that they did.
Oh, I
You
know.
know, even if it's not functional, the only reason that they meaningfully functional, I mean, you know what I mean? Um, the only reason that they wouldn't is the growing acceptance of the fact that it's a total fucking waste.
Well, they built the whole
So it's
Olympic
like, oh, okay,
Stadium,
cool, you
and
put your money away, and we knew that the money's been pissed away for a long time. And that's, by the way, why the United States, in my opinion, this is a fringe theory of mine, okay? It's why the United States, under Ronald Reagan, when they were supposed to build that huge collider in Texas in the 80s, they didn't. And then Europe said, oh, well, we'll do it then. We'll do it. That's fine. And we're like, yeah, perfect. Go ahead. It's because we already knew all the answers of all that shit. Man. We already figured that. We already figured that part out. And we're like, well, why we're not going to do it then? That's it.
can you imagine, Joe? What
That's my theory.
it's just okay. Here's a stupid thing. Okay, I'll just tell it to you out loud. With all the people that watch this channel and what everybody does, and then I get a lot of contact and email and what everybody does, you know what I mean, and shows me different things. If we literally just came together and did it, 30 grand, and boom. Do you know how much different equipment would come out of that? like modeling programs, sensors, everything you could want, and then you take, you know what I mean, all of our collective understanding of how things are actually built, and you had no problem building it, and you got somebody who kept everybody on track on the different builds of everything. I mean, look, we can extend all the science about what, take away 50 years off of science of getting there by just because we know where the things are supposed to go and how they're supposed to build, and we're not playing games with things. You know what I mean? It's
Yeah.
it's not a, stick in the dark. It's I know what the hell has to happen.
I mean, my opinion of this is to be able to take all of this, all the theory, and then all the tech, and then bring it to a point where it's developed extensively enough that it's able to then bring in a bigger investor, is 5 people with 2 teams of 2 and a floater, that floats back and forth, and $250,000. So that's my opinion. I think it's $250,000 and the effort of 5 men.
I don't think you need that much.
I mean, I'm talking about to the point where you could literally go to any like investor at that point and be like, hey, look at what I got. We need to expand this further. This is what we have. And the only thing anyone you approach would ever do is pull out a checkbook.
Yeah, look, I understand, but if you bring in an investor, there goes any opportunity to share it with everybody else. That's the biggest problem with an investor. It's different than doing this stuff on your own and giving away the information for free. I have no
Well,
plans on selling
you
anything.
want to know something? Sometimes investment comes in a funny way, because the investment isn't necessarily a direct return on marketable investment. Sometimes just being able to, ruin someone else's day is grounds for an investment and a good business move for people. Like, there's certain industries out there that would benefit massively by not being beholden to a power company or
Yeah,
whatever have you. You know what I mean? Like, you wouldn't have to ever market anything as long as they could develop it and have it. Like that's
well,
the point. Develop it and
that
have it, not become beholden. They don't need to make a penny off of what happens, and nobody does.
that's still the problem, though, is they're going to hold it. You
Yeah.
see, that would be against what I do on the channel. You know what I mean? Because I don't hold much information unless it's
Well, that's not. It's not about
destructive to
withholding.
people.
It would be about putting it out there. Actually, the point is, as long as they get it, then it's good.
Well,
And if they don't, then they spent money to try.
here's the thing. It would have to be not wait until we hit a certain point in the understanding of it. It's as the tests are going on, it has to be published. And that's the only way I would do it. And as soon as
Well, it's the only
that
way.
stopped in any way, if that stopped in any way, we would be done
Yeah, I agree.
immediately.
No,
I
I
wouldn't.
agree with you wholeheartedly. This from the beginning has always been exactly that, and
Yeah,
can't be any other way.
it's different than saying, okay, I'm going to take a government contract. I'm going to go, live wherever the hell they tell me to, and I'm going to build what they ask me to build, and I'm going to walk away at the end. That would be one thing. That's not what this channel is. This channel is,
No, nothing
it's,
like that.
yeah. So I'm not into, weird investments, things like that, or somebody who wants to get something out of it. I'm not into that at all. You know what I mean? If I wanted that, I could have had that already. I'm not looking for that. And I don't want anybody to be able to proprietarily take my information, you know what I mean? And just use it everywhere. Once it's out there for everybody. I want to be able to have anybody shut it down.
Yeah,
So,
I mean, Aaron said it, but there is such a thing as philanthropy. Never said, but like philanthropy. Where realistically, just doing it for the greater good of humanity. Putting it in just to see the beans meet the end. I'm not saying that opportunity exists or doesn't, or whether it did, if it's an opportunity worth taking. But the idea here is that none of, even where it's at, it's doable with a couple of good minds thinking about it, 1 or 2 people trying to do it, and less money, but just simply makes for better TV and takes more time. You know, at that
No,
point,
I
and
understand
that's
that.
the reality of it. Because I think that within 12 to 18 months, you know, all hands on deck and proper funding, you know, the thing is solved in 12 to 18 months.
Well, yeah,
That's,
that's why I'm hoping this next year is like you said, you hit a threshold and then we go forward.
Mhm.
I'm really hoping that's the answer, Joe, because then within the next year or two, I'm golden. I don't have to do anything else. I got it. You know what I mean? That would be
That's it.
that's it. That's straight
Then
up
I can go
answer.
back to my painting. You know, I just be like, oh, nah, I just paint.
Yeah, I don't know what happened, man. If you just threw it out there all at once, that'd be kind of crazy, huh?
Yeah.
Like it's here's the thing though, it's kind of hard, even though we know what the RAV is, it's hard for everybody to understand it. But then you do a show about it, and it has to become part of mainstream in order for everybody to really get it. Because I can't even get some people don't understand conversion of energy, or like we're talking about capacitance and filling up capacitors today, and then switching different energy forms no matter what the capacitance of the energy was. You know what I mean? That's kind of hard to relate to somebody or say, "Hey, I'm going to take a DC and I'm put frequency into it and switch this whole thing around." You're like, "That's mind-boggling, dude. How'd you do that?" Well, none of it's out of physics. As a matter of fact, it's all in line with physics. Is what I did.
Oh, yep.
It's just not well known. It's not something that everybody does. You know, engineers kind of keep stuff close to their vest, and if they put it out there, you probably still wouldn't understand a lot of it. You know, not right away anyway. It takes a little while to work with it.
Well, not to mention, engineers are just working with the systems that are in play that they have. So they have a grid or a power source or you know, being a battery or, you know, and a generator or a plug or whatever. They have to make things function off of those things, you know, and anything else that isn't what they're trying to make it function off of is a form of interference, right? So they're not trying to use the environment. They're just simply trying to use what's there and provided for use, right? So once you start tackling the engineering aspects of those problems with those prerequisite constraints, well, that means that everything else that could be coming in, you are immediately trying to push away from interfering, you know, because you want a pure, you know, amount of energy, a predictable amount of energy to do certain amounts and certain things in order to achieve your function. You know, once you start having all these other things come into play, well, then it just all falls apart engineering wise, and you avoid it at all costs. Which is why I said that they wrote the rule book, and the rule book said to avoid all these things that we're doing because they break the rule. But you know, so no, this does not give you a functioning device, right? Like it's not a circuit that's usable in the common sense of how we use circuitry, right?
Okay,
It's simply functional in the the precursor to what your energy source is. That's where it's fundamental, right? So that's sort of kind of why we have a show, isn't it?
so
Because these guys had it figured out a long time ago.
here's the thing, Joe. I'm just going to give you a straight up truthful answer, and it's going to suck for some people, and then it's going to open other people's eyes. All of these things that are said are over unity are over the value of the actual build. Yes, they're still not over unity. Okay.
Right. Who said that?
When, yeah. So here's the thing: when you have a closed and open system, yes, you have the value of the closed system. Okay. And you have an additional value of the open system. So you would say, I have over unity, right? But the fact is you don't. And this is where physics trips you up because instead of admitting that simple fact right there, okay, they don't tell you the other half of it. Well, what's the other half? What's the area of energy that you pulled the open system out of? Well, it's the Earth.
Mhm.
Well, now not only did you not have over unity, you have 0.00000000001%. Okay, at the end. And you're like, well, that's pretty crappy math for me, but does it mean that my system sucks? No, it means that your system not only gained back the energy to run it, but you have extra energy because of the environmental condition. What physics is saying is we are accounting for the environmental condition, whether you want to or not. So all of these systems do produce over the amount of the system itself, but they're technically never over unity. Are they
So,
self-run? Yes, but they're
so the
not
thing
over
about
unity.
unity is, if you think about it in context of energy exchange, right? If you have an even energy exchange, okay, great. Now, if you move it to a surplus where you're taking, you're actually on the gaining side of the equation, that's still not over unity in that context either. That's just a net gain, right? Over unity in that case would mean that the full potential of your system, like any capacity that it has, okay, is going to be overvalued by the exchange. Okay, so if the whole system is only capable of handling however much energy, you know, and you bring in a potential, it doesn't have to be in the current state or anything. If you bring in a potential value that is higher than the full capacity of that system altogether, now you're over unity. Because what that means is that that thing's running full go all the time, okay, and you could tap off of it, and everything you tap off of it is free and clear at that point. Because you're just taking the greater potential and that it could have never created, right? That's the point. It could have never created it, but it was able to bring it in. And in my opinion, the only way to do that is to, basically lock into phase with, if you look at the dimensional exchange that I was discussing,
Mhm.
if you were to lock into three-dimensional phase, the four-dimensional energy at its largest diameter, right? That's going to be your highest rate of exchange. Okay. So that's, in my opinion, what the definition of the over unity would be, is because you would need to lock it basically at the greatest diameter.
Well,
That way you
yeah,
have the most of it here.
but I'm just trying to make sure people understand, like Aaron said, it's accounting. So
Mhm.
those who don't do the accounting don't understand, where the energy is. So that's kind of what I was getting at here, Joe, is that these systems that we call over unity are not breaking physics to this day. So okay, say you want to make a rife machine, right? Pull the energy right out of the air. Is it breaking physics? No. Is it more than the system would normally have in it? Yes, it is. It's not breaking any law. It's just conserving it. It's conserving energy. You're getting this thing that has a lot of energy in it, but you're pulling out of atmosphere. You're not. You're not screwing with any law of physics. Because honestly, we'll never reach the point where you have more energy than the cosmos. It'll never happen. We won't reach,
Nope.
even if we use the whole planet for our energy source, we'll never have more energy than the planet. Those are facts. But where we're at is we have the shittiest system in the world to pull energy out of a generator. That is a simple fact. And what we think is a lot of energy out of it, and we're all excited about it, isn't shit. That's the problem with it. It's literally very low potential is what we're dealing with, and by changing just simply the way we see energy and how we work with it, it changes the amount of energy in the system. And I'll say this too: you think that the sun is over unity? It's not. It will die in time. It will never be over unity. You know what I mean? It is a simple running system that will die at some point in time, and it's done. That means it's not over unity. That means that in plasma physics, when you start talking about, oh, we got fusion, we got unlimited energy. No, you don't. You actually will never hit over unity in that system. Will it become 99.9% efficient? Yes. Will it hit over unity? No. Okay. How you get the energy into it matters. Okay. And when you start putting all that stuff in there for a bunch of magnetism that doesn't belong there, you reduce the amount of chances by 30% at minimum of pulling any energy out of the system. You've already wasted a ton of energy. And why? Because you want to make a fucking donut instead of a sphere. And
That's true. Right.
you
You
know
got
what I
to
mean?
remember that this
It's a complete waste.
this whole thing is this exchange that we're discussing and what we talked about a few weeks ago. Once you realize it's an economy, like that's sort of the reality of it, and it comes down to if you can say, right, like, well, how much money do you have? And you could say how much money you have in your bank account, or you could say how much money you have plus assets, or you could say how much money you'll have kind of like next week, knowing that you get paid on Tuesday, or you could say, well, I have this much, but I also have the potential of every dollar on earth, right? Like, obviously, there's not a situation where, you're going to be able to do something to bring every dollar on earth to you. However, the reality is your potential of earning, right? If you were to project into the future, right? Your potential of earning is exactly that. That's your pool, is every dollar.
So, okay.
So you potentially could have every dollar, but you never will.
No.
But that's sort of the idea between the potential and then the exchange and the exchange rate. It's just that there's not necessarily a set amount, but that set amount is always how much you could grab. But just because you could doesn't mean you can. I know that that's convoluted, but
No, I get it. But what I'm saying is, okay, we know the pyramid can be used as a capacitor, right? This is the stupidest part about this whole thing. If you take the Wardenclyffe Tower and you remove all pre-existing conditions that you put onto it and just make it an antenna, what do you actually have? You have a ability to pull the energy out of the air, and you have the ability to pull the energy out of the ground. Where they meet is capacitance. Okay, that's it. Okay, that's not a small amount of energy. That's a ton of energy. Here's the thing. If you did that all around the world, guess what? Now you're using the energy of the world for everything. Do you need to pull any fossil fuel? Absolutely not. Not one
no.
single bit of it. That's it. That's the dead end. There's enough energy there where you can continuously do it at all times. And if you just saw it that way, get rid of all the things you think of what these things do and really realize what they are. If you talk about a pyramid and you put an antenna on top and you know that the pyramid itself is a high voltage capacitor, then guess what? All you had to do is pull the energy from it. This is as simplistic as it gets. Is it over unity? No. Is it more energy than we can ever use as human beings? Yes. Okay. Does it deconstruct our planet in any way? No. That's the point.
Well, right. It's also renewable because the energy can't be destroyed, and realistically, it just gets put back into the environment to be recycled out. And the thing, and let that be the moral of this particular episode is it's like I said, the potential is everything that's out there, but that's not what you have at your disposal. However, what's the determining factor in the context as to how much you can capture is a capacitor. Okay, because that is the well to store, and then the ability to to normalize and discharge. And that's your capture. That's your bank. That's your ability to take from any source of energy and then be able to to use it in that circumstance. I mean, obviously, it's not the only way to store energy and capture it. Okay, but that's only because other things that do it are acting as with capacitance. You see?
Okay,
So
but
it's the same thing. It's just doing it through a different way. We define them different, but what do you think a cell is? A cell is a capacitor. It has a capacity, you
yeah.
know?
Well, okay. Remember how Sean does this? Bit of energy on a cathode sets a condition. Then the energy comes down and hit it again, creates the RAV immediately. If all you did was the top of the pyramid is hit it once with a lightning bolt and set the condition, it carves out all the caverns it needs and sets a condition for the RAV to appear. Then the lightning bolt that hits it next just feeds it and builds it. Look, it's ball lightning. It's that simple. It's an energy state. It's proven already. And all you do is pull the capacitance out of it into the pyramid itself. Okay.
And it's exactly how the RAV works. You
Yes.
have a high density, high concentration energy at a point through a substrate. The substrate connected to its own separate energy potential that and at a much more diffuse rate, but far reaching, right? Far reaching, diffuse. And it's diffuse because it's just a lot more mass. So the energy potential that's high density, okay, actually has a lower energy potential as the sum of a whole. Okay, then the diffuse energy. Okay, so it's inverse. High density, lower potential versus lower density, higher potential. And that's the deterministic factor of an anode and cathode, as we've discovered. Um, that's exactly how you get the effect. So when you
So
have a huge pyramid, huge mass, and then it's also hooked up to tunnels that pipe down and etc. Well, you have a massive amount of mass and a massive amount of potential that it's contacting at any
so
point.
they gotta remember how the double RAV works and a triple RAV works. You put the energy on one side, okay, with the anode, and then the cathode goes to 1, 2, and 3. So what does it do? It hits an energy here, pops out of here, goes into the next one, hits an energy here, hits the next one here, then comes back to the original source. It's the point of doing the experiment. We've already done this with RAVs, and that's what it does. You're going to make a pyramid structure, and then boom, it's going to pop in here, hit it shrink, and then go into the next one and pop up, and then shrink, and then go into the next one. But that's exactly the flow pattern you need when you're over there making ammonia in pyramids. So, you know what? I'm just trying to say that we're not violating any physics here. For those of you think that, hey, my system got more energy than it's supposed to, it's not violating any part of physics whatsoever. Okay. It's the accounting that has to happen that puts it back into physics perspective. That's fine with me because I'll be honest with you. If I have a system and I'm getting energy out of the atmosphere, I'm the luckiest sucker in the world, okay? Because I did it right. And now I have something that I can run my home on, okay? But I'm not violating any laws of physics to get there. I'm just doing the correct accounting by saying the extra energy I'm getting is from the actual world itself. So I'm not breaking any law, but I am powering my home and using the energy quite efficiently. That's as easy as it gets. So, yeah, I don't think people really realize that when they do that, when they talk about over unity and what it actually means. They look at lumens and stuff like that and they go, well, I got so many lumens, so I have over unity. No, you have to qualify it for that. You don't actually have over unity. What you have is a highly efficient system that's over unity for the system, not over unity in general. And I wish they would come up with another word for that because it would be a really great distinction point.
Yeah, would be. I mean, I'm kind of like looking at it right now as you're talking, and like the inside of the Great Pyramid is actually kind of interesting because the way that they have it mapped out, and who knows how accurate any of it is. I'm assuming that what they're putting here is there. Who's to say that there's not more or whatever have you? But what you end up noticing is that the um the shaft that goes to like that main thing, what do they call that? The bell stairs. right? Or bell stars or something, right? Well, it's slightly off the central axis, slightly off the central axis. Hear me here. All right. And then you have the king's oh, that's the king's chamber. I'm sorry. I don't know what I'm talking about. King's chamber, okay? So that's slightly off the central axis. Then you have the queen's chamber down below that, okay? That's slightly off the central on slightly off the central axis in the opposite direction, okay? Then you have the what is that? A subterranean chamber, okay, that's under the rock, and that is on the central axis. So if you draw a line straight up, what you notice is you have one thing slightly to the right of center, one thing slightly to the left of center, and then one thing all the way underneath dead of center. Well, why? Because if you have dead of center at the top and dead of center at the bottom, those are your primary sources. The thing is that the way that the energies route with each other, they come at each other from opposite parallels, right? If you take the 52-degree slopes into equation, okay, and the approximation of the axial spin that we see on like the RAV when it develops, for instance, right? If you pull it too far off center, it'll always correct to get the correct angle, which I assume that angle is directly correlated to probably the polarity, right? And adjusted, it still goes off axis, right? So they're trying to get something to spin center, basically, Queen's chamber, and the way that they're doing it is by offsetting the anode, the cathode, in my opinion. So it's quite possible that those are all the leadways that make such a thing happen and occur. And it'd be interesting to know.
Well, I agree. It's going to change the energy inside and where it directs. That's for sure.
Yeah, I'm sure that if I plugged all the main points and drew lines, I bet you that something would emerge. Some type of geometry would emerge, and it's like, all right, now we can see that here. You know what I mean? And
well,
seems to be consistent. I'm looking at this real time, so this is how my thought process goes.
no,
Sometimes.
they found a chamber that went up somewhere. Okay, a little box area. They ran this thing in there, and it came up, and it came to like what looked like two bolts hanging out of it, right? But what is that? That's an anode and cathode in your situation, right? That right there could be able to start a RAV in there, no problem if you did that. But they have
Mhm.
other chambers that are undiscovered. I think that they literally have a chamber in there that builds RAVs inside of it, and you know what I mean. They use the energy in order to put it through the other pyramids because it's the most efficient way to do something. Because it takes your spark gap area, okay, turns it into a RAV, and then that lowers the temperature of everything in your system, so that when you're playing with ammonia, you do not get it to explode. Okay, it's a very critical factor there. Okay, you do not want to overheat and play with this stuff in the wrong way, but that's kind of the point, and it shows up anomalously in certain systems, and we don't notice it all the way. You would have to understand what it's doing to see it all the time, and I don't think people do. I I don't know how many times I've heard, oh my god, the temperature went down and started running more efficiently, and I got a ton more energy out of it. Well, why do you think that is? Something in your whole system aligned, didn't it? Something on your frequencies aligned in your system in order for allow it to flow. And they go, well, I have a DC system. Well, do you even understand what you're doing with each part that goes into it and what the frequency is of each part? Because if you don't, your level that you think sits here is now going to start jumping and playing on you. And I just, it drives me nuts, man, because I do systems all day and I go, you have to fix that. Or one of my favorites, Joe, that I've seen
Mhm.
is you don't understand. Every time the piezo goes off, okay, it puts out a wave. If you hit another piezo after that, right? You need this one to hit it in a constructive way to amplify this one, okay?
Mhm.
And I can tell you by looking at your screen and where your frequencies go, when you failed. Okay, immediately as soon as it went off track. Why? Because what you see on the oscilloscope is you get a spike and it goes like this. Okay, and then it hits this one, and instead of it going bigger, it went and then all over the fucking place. And you're like, okay, you screwed something up because this is no longer pushing the second one, right? It has now hit something else in there, and it's either hit the edge of it and it went straight up and down on you, okay? Or it hit a point in the middle of it and it just dumped the energy of this one and you only got this one going forward, right? So I already know just by looking at what your oscilloscope told me where you hit it at. And your goal was hit one, hit this one in amplification, and then go to the next one and amplify that, and then amplify that, and then hit the end, and then we got propulsion going the other way. But that's not what your oscilloscope says. It says,
Yeah, right. I mean, when you think about wave collision as a form of gearing, where the energy dump leads to the scattering and refraction in another way, but whatever it hit is actually now has the energy that was lost, right? It wasn't lost; it was just transferred. And then when after it was transferred, well, it changed. I mean, first of all, this is how radar works, right? We all know that. You send out a radar signal. Okay, if it doesn't interfere with anything, then there's no blip. But as soon as it hits something, well, that crushed the waveform. The crushed waveform gets thrown back to where it came from, but in bits and pieces. And then those bits and pieces are the data that allows you to tell what it is, how big it is, maybe what shape it is, etc. But the energy that hit it and returned, it lost a lot of its energy, which is how that data is formed. The waveform might have lost it, but what it hit gained it. So whenever that happens, that there's a pressure that's occurring. That when it's powerful enough, one thing might just, it'll actually move rather than just refract out, especially if it's another field or it's waveform. It's just how the interference of it all goes, but it's all usable because this stuff is around us all the time.
So let me go back to my analogy, Joe, real quick. How do you create that? Just like you said, in a radar. What do they use in a radar? They use a resonance chamber. What does a resonance chamber do? It's like a distributor in your car. Okay, there's the cap. It literally sparks one to the next, to the next, to the next. But everything has a set distance. Okay, for everything that it does, it's a geometric pattern that it's following. Right. I need to go this distance to get to this distance, and then that's a frequency. Then I go this distance, a frequency, but it's completely set. So every time you put out the wave, it's naturally going one to go to the next, to go to the next, to go to the next to build it. That's why it can amplify the frequency coming out of your radar. It's as simple as it gets. You're setting it up in the most consistent way possible because each one of the things inside your magnetron is set up for an equal distance in between them on each one of them. So as soon as it comes here and it goes boom, energy here, energy here, energy here, energy here, we're working like a clock. Now I can't change the distance on any of them, which I don't want to, because now I have every single one of them going out at the correct wavelength, right? That's the point there. That's what they're missing in their system. They look at it and go, I put one frequency in, it didn't work. Well, of course it didn't work, because they all have to do 1, 2, 3, 4, 5, 6, 7. You know what I mean? And go boom, 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 boom. You know what I mean? You're literally creating that. What was it? We saw it out of the back of the jet, the ramjet. It was going boom, 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 boom.
Yep. That's when it goes right. That's when it goes into a full blown pulse at that point.
Mm-hmm.
It's pulsing because it's in resonance with, like, everything has fallen into sync between the rate of combustion, the fuel flow, the airflow, and the crazy thing about, well, ramjets are cool, but scramjets are cooler, right? Like, crazy thing about scramjets is that there's nothing in the middle. There's no fan, there's no anything. It's basically working at that point like an open rocket where the pressure of the air passing through is deterministic of the feed. which leads to further acceleration, which leads to further fuel consumption and combustion, which leads to more thrust, which, it's a perpetuating cycle. And it seems like the only limitation of that tends to be drag. But if something has a scramjet attached to it, chances are they figured that one out pretty damn good, probably with a lot of, things that we talk about, like, maybe separating your inertial, planes and then so on, plus aerodynamics, obviously, if that's still in play, even if it's just minimized inertial influence or whatever. Thing about going that fast is what happens when you move. If you think a plane like that can turn.
Oh
Well,
God, the
the
G-force
thing
in
is,
that.
the G-force, the G-forces would rip you to shreds.
Like on a
So
straight line.
right. Oh, we're going really, really fast. Okay. All right. I hope we're headed where we're going, because if we're not, we ain't never gonna get there.
Hey, it reminds me of the football players when they're in there and they, hey, I won the Super Bowl. Hey, get in my jet and let's go haul butt, right? And then they just put them to the wall. You know what I mean? Oh, let's see if you pass out as soon as we hit the certain G-force. You know what I mean?
Mhm.
That's what reminds me. It cracks me up when they get there, because the toughest guys in the world, you know what I mean? That ultra tough walking on the street. As soon as you hit a jet plane, you're
Well,
screwed.
also tough. If you weigh 350 or 400 pounds because you're a lineman going to play professional sports, what you weigh 2,000 pounds at, you know what I mean? And
Yeah.
3 meters or something for a brief second, you weigh a ton.
Oh,
So the bigger you are, the harder it hits. That's how that goes.
oh, the pilots probably laugh their butts off on it too. That's great.
Whoa.
Yeah, because you literally see them fall asleep like I do, like watching my TV, and they're like, ah. You know what I mean? The next second they're puking. Yeah. They
Dude,
get them
that's
good.
how I smoke my neck, dude. And just sit there, I fall asleep watching television or something like this.
Oh, yeah.
You know what I mean? I'll wake up, I'm like, oh, it all is bad. Why'd I do that? Oh,
I
boy.
get the same thing, Joe. Oh,
Yeah.
man. It's always fun to talk about this kind of stuff, man. I like this.
I saw a bed one time that they make, Nathan,
What's that?
that has it has like a slice in the mattress
Uh-huh.
where you can shove your arm all the way through the mattress.
What?
Sort of,
Why would you do that?
so you don't have to sleep with pressure on your shoulder.
What?
Yeah.
So in the mattress, by where your head goes, there's an arm hole.
Your mattress is here, and your bed's off the thing. So literally, your arm it has like a couple of slices, depending on which way you're laying or whatever, and your arm just goes through the mattress, so you can sit there and basically just be like this, and then there's no pressure on your arm because it's all dispersed.
So where does your hand go? Does it go under the bed?
Well, yes.
Oh, I don't even like the whole idea of that hole. That's like a secret hiding hole for something, or something.
I mean, listen,
That doesn't sound right at
I mean,
all.
as much fun as you're gonna have for something that you could stick your whole entire arm into. You know what I mean? Like, yeah, maybe. Like throwing a hot dog down a hallway. You remember that?
Oh, that was great. That was funny. Oh, Mike and his coil cracked me up.
Yeah. Looks like a carnival game.
Yeah, just don't turn over with your arm in the hole.
Yeah.
Oh,
Well, yeah, that's it. Then you get snagged up and stuff. I know. Whatever.
I think it seemed like a great idea, and I don't think anybody bought them.
I don't think so either. I mean, honestly, if you have a memory foam mattress, it's a problem that you could solve with a razor blade. You can go box cutter and go to town on the thing. Be like, oh, wow, this didn't work good. Oh, what did this mattress cost me? Oh, like $2,000. Oh, all right. Just put a sheet on it and forget that I ever did this.
Oh my God.
Because then you have to have a sheet with a hole in it too. It's like, where do you have to go to buy one of those? The Hasidic store? Anyway,
Sends all the wrong messages, man.
it's like what are all these non-Hasidic people doing in our Hasidic store? It's like, oh, they have shoulder pain. They need sheets with holes in them. Anyway, terrible.
That seems like a grab asshole for your wife or something like that. You know what I mean? Hey, you got an invader coming. It doesn't sound right. Oh, God. Oh, man. All right, Joe. It's been 3 hours, man. I think we're about done for the night, man. So,
I think so. I promise that we'll do something productive next week. We'll talk about something productive.
always fun, man. Always fun. Right on, guys. Happy New Year's to everybody out there, man. I know mine's been good. How about yours, Joe?
It was good, man. 2026 is very promising. I'm looking forward to it.
Right on. I want to thank Darren out there for 5 Old Man's Build memberships, man. Right on. I gave out 5 as well. We got Darren over here with a super sticker for $10, man. Don't forget about Joe over here. He's going to be putting these things out right here with Tesla. These things look amazing, by the way.
Nice and clean.
Yeah, I'm excited, man. I want to get mine. So we'll be putting that up here pretty soon. We'll let you guys know. With that said, man, I want to thank everybody in the chat for watching, man. You guys have been great. Anything for you, Joe?
Nope. Limited to 25. They'll be on sale next week. Peace and love.
Right on, guys. Have a great night, everyone.
The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.